And today we're going to be discussing lesson number 2, how to design highly available, cost-efficient, fault-tolerant, scalable systems. Let's skip straight to the slide number 2. In today's sessions, we're going to be discussing a few of the concepts. For example, we're going to know how to design cloud and what is actually the difference between cloud and normal infrastructure, as per this particular slide here. Also, we will know what are the well-architected frameworks and what are the best case scenarios and why. We'll be discussing how to plan and design a cloud infrastructure, which kind of can differ from a traditional one on-prem. We also will be discussing monitoring and logging tools available that we kind of mentioned yesterday, but today we're going to go a little bit more into details, which is really exciting. And also, we'll be discussing a hybrid cloud infrastructure, what it is, how we use it, and why would we potentially want to use it. So straight away, I'm going to jump to the next slide, to the overview of the design. In this slide deck, we're going to be talking about overview of the whole cloud design and all its principles. So, designing cloud services. We'll be talking about frameworks. We're going to be talking about 4 fundamental pillars of AWS, which is security, reliability, performance and efficiency, as well as cost optimization. We'll be digging a little bit more into the searching for relevant information, where you can get it, how you can search for it, and pretty much the most up-to-date sources you can get it from. We will also have AWS Quick Start reference deployments, as well as final real-life examples. And that particular one here, we will be digging into how actually it is to log into the console, how it is to start doing things, which I know you cannot wait to do. So let me skip to the next slide straight away as well. There are 5 principles of well-architected framework, and they are as following. Stop guessing your capacity for your needs. What it is, I will describe this as follows. Basically, if you think about the traditional data center, or you think about on-prem servers, and you have a project to fulfill, you need to always plan ahead. You need to know how much hardware you require. You need to know the network capacity. You need to know the storage, compute, and many others. You need to pre-order this up front. Maybe you have already hardware on site. However, the cloud is fully flexible. You don't need to pre-order anything. You can click on "I need more resources," more or less button, and you will spin up more instances. You will spin up more storage. You will spin up more resources whenever required. And if you don't need it, you can quickly scale it down by decommissioning the old servers or reducing number of storage you require, hence paying less. It's fully scalable, and whenever you need it, it's available to you. In point 2, we have test systems at production scale. This is very important. Now, why it's important is as follows. You want to test if the production system will be able to handle a specific amount of traffic. You want to test how it actually performs. Maybe you need bigger boxes, maybe you need smaller boxes. And it's actually very easy. You can deploy a whole system with pretty much 2 or 3 clicks that we'll be showing maybe a little bit later. And you'll be able to create whole environment by basically following simple next, next, next button. And within a matter of minutes, you have production scale environment, which is exact copy of your dev or QA, which is absolutely amazing. Also, you can lower the risk of architectural change. What it means is, because in AWS you can programmatically change every single resource, because remember, AWS is an API-driven infrastructure. Basically, you treat AWS as a code. You can program everything, and because of this, architectural change is much more difficult to be implemented by mistake or changed, because you reuse the same code, so it's not human error anymore. you can automate stuff, which is the biggest advantage to you guys there. The reason is, when you reuse the same applications and systems and you're trying to basically build to the same standards, you can create templates, and those can be fully automated, which means you only commit time once, and once it's done, you never ever have to redo it again, which is absolutely awesome. And one of the last ones on the list here is allow evolutionary architectures. What does it mean? Imagine you have current system that you currently supporting and maintaining, and it's great. However, there is a change because someone wanted to introduce a new web service. Someone wanted to add additional database, and that's actually simple. Expanding current systems to additional resources is extremely simple, and it doesn't require any pretty much knowledge above what you already have, which is absolutely great. Let's skip to the next one. So, stop guessing your capacity. Imagine you are dealing with a new application for your business, and all the infrastructure decisions are made using pretty much estimates or guessing. You might overestimate and end up with buying too much hardware, resulting in expensive idle resources. We all been there. We all know that those systems and servers that you're currently supporting or working with, they're pretty much underutilized. Funny enough, every single environment I worked for and with, average utilization of the system, no matter if it's one server or 100 servers, was below 10%. 10%. With the normal hardware, if you have this sitting in your rack, that's maybe acceptable because you purchased this and you're now using whatever you want to use. In the cloud, however, you think about this a little bit differently. Reason? Because you pay per hour, as we discussed this before, which means if you're paying per hour and you're only utilizing 10% of the resources, it doesn't calculate. It's not worth. It's much better to increase amount of decrease server size, or maybe decrease the fleet of servers, so reduce number of servers, to utilize a whole stack that you just spun up in a much, much better way. So, for example, I'm going to give you a very, very good one. We have a database. Imagine that the database you have is average medium size. You notice that the database itself is only using 5 to 10% of capacity of the CPU and memory, and you're still paying for a whole 100, which means you don't use it. In this case, you can simply reduce size of this particular database, keeping the same data as it was, with a few button clicks. Really, you wait around 5 minutes, and boom, you have a smaller server. You utilize the server now to maybe 40–50%, which is kind of a sweet spot you always want to be around, and then you're actually getting good value for your money. The same applies to networking. The same applies to pretty much every other field here, which is absolutely great. And you're gonna find it that managing costs suddenly couldn't be easier. One of the most common problems people do, and quite likely you will do the same at first, is you will overestimate the size of your environment. You will do much bigger boxes that you actually need. The reason for it is you don't really know what capacity you require for your application, what systems are using, and in what way they're going to be used, which is great at the beginning. But after you running production loads through them, and you notice that, hey, actually databases are not used that much, or maybe I have way too many web servers, you can simply reduce, which means the cost, if we're going to have a chart here, the cost suddenly can reduce, and once you find the sweet spot, then the cost here is fraction of the cost that you had it here, which is exactly what you're looking for. And you can do this over time. You can scale it up and down, whatever you require. I have a good question here from Ravi Babu, saying that sometimes we don't know what the load will be, and that's a very valid question. Now, imagine a situation, we are running a store, online store, and that's going to be a load chart here. The load chart of your systems. Now, that's 100%, let's say, 100%, and that's time, right? So your systems are kind of running, I'm going to draw a days in here. Now, during the day, your systems can be used a lot. During the night, probably less. During the day, a lot again. During the night, less. And that's kind of a normal behavior. But suddenly, on this particular day here, you have a sale, or maybe you posted a link on the social media with a link to your store saying, hey, buy it now. And what happens is suddenly you have a spike. Quite likely, on the old systems, you would reach this particular point here, and pretty much that's it. You would cap out the capacity of your system, and they would stop working. Well, with AWS, you probably won't have this issue. Why? Because you can use so-called systems like auto-scaling, which means that if your system ever detects that is beyond a specific level, let's say 75%, just to make it safe, and that's the chart here. If the system detects that goes beyond for a specific amount of time, like 3, maybe 5 minutes, what it can do, it can add automatically additional servers to the pool, which means the traffic suddenly is being spread across much more servers, which means the traffic, you will notice it will drop. Now, you can also specify this other way around, which we're going to discuss in the future. If, for example, the traffic falls beyond below 50%, sorry for my drawing, what can happen? The auto-scaling itself can remove the servers from the pool just to make sure you're keeping the sweet spot around here. Now, that's one of the uses of the system, and that allows you to actually have amazing cost saving, especially when you have a night period. That means that the number of servers here can go beyond below, let's say, maybe 5, maybe 10, depending on obviously what systems you're running. And you're saving money overnight because you don't really have much traffic, yet you keep enough servers in the pool to have a redundancy. So let's say you want to have at least maybe 2 or 3 servers spread across different AZs, which means if one server goes down, it doesn't really matter because you still have 2 healthy ones. And that's exactly what we're trying to achieve. And that's exactly why you stop guessing the cost and the capacity. So I have another question from Akshay. Its number of servers, does it mean additional CPUs? Yes, in some way it does. When you think about the instance or a server, it's a fixed. Its server consists of CPU, memory, and hard drive. Which means every single time you spin up additional box, and bear in mind you can spin up different size of the boxes. You can have a small ones, you can have a large ones, you can have a different kinds. You get guaranteed amount of CPU, memory, and the drive, and you can make them smaller. You can actually make more of the same boxes, which actually means yes, more CPU and more processing power. So yes, those are exactly what we are talking here about. So let's keep to another one. We can test system at the production scale. Traditionally, in a non-cloud environment, it's very difficult to actually completely test new products or services in development, and its cost is really difficult to guess. Well, in this case, projects will go wrong as soon as the production goes live due to inefficient testing, and that's very, very common. With the cloud, you can create duplicate environments. You can on demand to test the new product. After completing the testing, you can then shut them down, and you don't pay for them, which means every single time you actually run any resource on AWS, you pay for it. Every single time you shut it down, you don't. You only pay for storage if you're keeping anything. So it's actually a great place. And imagine a situation that you can test if the production system will be able to handle specific amount of traffic. For example, your boss came to you and say, "Hey, tomorrow we have a sale, and I think we're gonna have like 10,000 people on the website. Could it handle such a traffic?" Well, guess what? We can easily spin up a whole environment, and we can easily spin up the whole environment a specific size, and we can actually load test it with stress testing tools, and to achieve maybe 10,000 visitors over, let's say, 24 hours. Obviously, 10,000 visitors is not that big number, but imagine you have a 1 million, you have 10 million, or so forth. You'll be able to test it ahead of the time, and if, for example, your test come back faulty, that the system cannot handle this, well, you will know where the bottleneck is. Maybe the database is a bottleneck. Maybe the connectivity between servers is a bottleneck. Maybe you need bigger instances. You'll instantly be able to tell how well the production will perform before you actually go into production, which is extremely helpful, as you all can imagine. Let's go to another slide. Sorry, yeah, one more thing regarding this one. You can also create duplicates of environments in a very simple way, and that's one of the big advantages. In the traditional data center or on-prem, well, you can't really create any duplicates. You have fixed amount of servers. You can maybe dedicate few to non-production. You can dedicate few to others. Bear in mind, those servers might be different. They might have a different CPUs. They might have different capacity. They might have different drives. Some of them will have magnetic. Some of them will have SSD. And all of those things and performance of each box could be different, and you won't be able to determine the real performance in the real time. With the AWS, you can duplicate the whole environment with really few clicks, and you can deploy it multiple times across the world if you want to. And in this case, you have exactly the same copy of all entire environment. Just copy and paste, simple as this. So another thing that is worth mentioning is that you can lower the risk of architectural change. What it means is with AWS, you can automate the creation of test environments that emulate your production configuration, which means you can carry out testing easily against pretty much similar environments. You can remove testing bottlenecks when teams are kind of, testing them. With AWS, you can create as many test environments as you really need or want. You can keep it to minimum to be cost efficient, or you can spin up many to test against QA. You can test against staging. You can have different environments, and that's the really beauty of the whole concept. I have a question. From Bavish. How about masking of production data if used for non-production dev and QA? Do you have a tool to do that? It's actually very when you say masking, do you mean restricting or hiding the production from non-production environments, or you want to reuse the same data as production into non-production environments? Which one do you really mean? I'll be able to answer this question. Okay, so it's a hiding data from non-production environments. Yes, you can do this. Basically, what you can do is you can duplicate the databases, and you can drop the whole schemas from the databases. But the whole concept really of testing how it would behave from in a non-production environment would be to have exact copy most of the time, so you can actually test it on the real data and as close to the production as possible. And that's the advantage of AWS. You can actually take a quick copy of your any system you want or any environment, duplicate it somewhere else, and actually run the test that would be exactly the same. And that's the beauty of it. But yes, you can actually use different tools, which I can discuss with you a little bit later, because we're going to be doing a little bit more of automation and other things. So I can actually mention this a little bit later as well. So as I said, you can remove all the bottlenecks. You can find all the issues before you actually go into production. So next slide, automation. It's extremely good. And once you actually go onto the AWS and you start using AWS automation, you quite likely will never want to go back to the normal systems. The reason why is it's so simple, and you commit time only once to deploy something, and then you can basically copy and paste the whole environment again. You don't have to set it up again. You don't need to deploy the same boxes. Imagine in your data center or on-prem, you have a bunch of servers. Someone asks you to deploy a whole environment, right? And the environment consists of few servers. You have, let's say, 2 web servers and 1 database server, and that's great. You set up from the beginning. You basically purchase hardware, you install OS, you install all the applications, configure all the network, security, you name it, and then you configure database, prepare it with the data and all this stuff. Now, someone told you, hey, I actually want the same thing again, but this time it's not going to be production. Well, guess what? You have to do it pretty much again. Yes, you can use maybe some script, you can use maybe automation tools like Chef and others, which, if you know how to use, it's a great thing. But most of the time, because it's a small system like that, it would be quite likely quicker to do it by hand, which is not ideal, because quite likely you're not going to do exactly the same, despite the fact you will try. Something always is different. With AWS, it's as simple as you take a copy of this and you deploy copy somewhere else, and it's exactly the same, including all the data on the drives, including all the settings and all the data on the database. Copy paste, and automation is exactly what we're talking here about. I have a question from Ravi Babu regarding what kind of tools generally are used for the automation in AWS itself. Well, it's a good question. AWS itself provides you with a built-in system called CloudFormation that we will discuss in a few moments. And the CloudFormation is actually a language that allows you to pre-configure every single resource you can think of in AWS and basically deploy it as many times as you want. You can use other tools, like you can, for example, if you have a AWS EC2 instance, so basically a server, what you can do is you can convert it to so-called AMI, which is actually an image of the whole server. And then once you have this AMI image, you can deploy hundreds of them, and they're going to be exactly the same. So whatever you took a snapshot of this in time goes to AMI and being deployed again. Regarding RDS, for example, so the database itself on AWS, you can take a snapshot in time and you can restore to any number of databases. So AWS provides you with amazing tools. Basically out of the box, you all you need to do is click, I want to basically a copy, I want to create AMI, I want to have a snapshot, and all of this is available. And you're gonna find that creating additional boxes was never simple, more simple, and you quite likely will never want to go back to the physical, as I don't tend to do, only if I have to, and I don't do this very often. So another slide, if we can do. Evolution of architecture in additional environments. Imagine architectural decisions are usually implemented as a static one-time event during the lifetime of the system. In the cloud providers actually the cloud provides you a capacity to automate and test on demand. This lowers the risk of design changes and makes implementation of innovations and new features easy and actually quick, which means that you aren't stuck with the last year technology. You always deploy the latest ones. I had a question from Vikas. AMI and snapshot works in conjunction. Yes, actually it does. When you think of AMI, AMI is a physical copy or a digital copy, think of that, of a whole server. What snapshot is it's a copy of the volume or of the hard drive of this particular server. So AMI, if you think about it, consists of a server settings and the data, so the snapshot. The snapshot itself is just a snap of the data that you had on the drive without actually server itself. So those are actually combined and work together. You can take individual snapshot of the hard drives if you want, because maybe you want to take a backup of your data and restore it somewhere else for later. But if you're thinking about the whole server and the system itself, you would quite likely take AMI copy, and then you can basically replicate it not only with an environment, but funny enough, you can copy the same AMIs across every other region, and you can deploy the same server that you set up, let's say in Dublin or in the US, in any other place in the world. And that's as simple as a few clicks, and I will be able to show you this later on during the session. Sorry, I had a quick water just to clear my throat so I don't squeak. Now, 4 pillars of AWS, which is well-architected framework that we're going to be discussing. First of all, security. As I mentioned to you guys before, security is something that AWS is proud of. They're actually market leader. Their systems are set up in the way that everything out of the box can be potentially encrypted, secured if you want to. It's up to you if you want to enable this or no. Majority of the things are enabled by default, but there are a few things like encryption of the data at rest, for example, which means encrypting the whole hard drive. It's optional. It doesn't cost you really anything. All you need to do is take a box when you actually create a server, and that's as simple as this. As I mentioned also before, AWS has multiple ISO certificates, and also they use in the US for the government to keep all their data. And I know in the UK, AWS is used by lots of companies, including MI5, for storing particular systems, so basically by police and government in UK to achieve the same thing. Additional thing is how reliable the system is. Now, I'm going to give you a little bit secret about AWS itself. When you think about, I have a question from Charanjit about is it compliant with HIPAA and PCI DSS. I'm not entirely sure about HIPAA because I didn't go as far as that. I know it's a PCI compliant and it's got all the certifications. You can download all the paperwork and everything from AWS to be able to pass the PCI with your provider. So yes, AWS is PCI compliant. Now coming back to how reliable the AWS is, a little secret from inside is if you think about AWS and the cloud, what it is and what it's actually built from. AWS itself is using extremely cheap hardware. It's using extremely small boxes. It's using extremely small components, and pretty much cheap is the name when you think of Amazon. You probably don't know this, but because they're using cheap the hardware and they're actually using Supermicro across the whole data centers around every single country in the world, what they do is they're providing hundreds and thousands of servers, and because of that they can achieve such a huge uptime, which means every single time you're actually on one of the boxes on one of the servers and you're using the resource, if this particular box is having any issue, they might switch you straight away to another box by simply just restarting your server, which means you will have issues, and I can tell you this for sure. We were running systems above 10,000 servers in the cloud, 15,000 sometimes, and on the daily basis we had one or two going down, and that's absolutely normal. Every single hardware in the world will eventually fail. I know you might have a service in Iraq that's running maybe for 10 years straight, and it's an amazing number, and it's possible to achieve. But when you think of a cloud, don't think that they're using state-of-art, most expensive hardware, because it's not true. Otherwise, they would charge you so much you wouldn't be able to pay for it. The whole beauty about the cloud and how reliable it is that they have hundreds of thousands of servers and they have not a single point of failure, which means if a single hard drive fails, they don't care. They have 100,000 in the rack next to it, and your data is replicated across pretty much 3 or 4 data centers in the same time, which means your data is always available. This is what they give you. Now, I have another question from Ravi Babu. If I want to communication across other than AWS VPC Prem, in this case, how security is going to be? I will discuss this with you once we actually reach the VPC, and then we'll exactly discuss this, which will be probably today. So I'm going to be able to answer this question, mention this before, after, and I will. Third thing, performance efficiency. Now, it's up to you how you're going to use the cloud. You have full control of the cloud. You can with a single button with a single click of the button, you can deploy 100 servers, 1,000 servers, even 1 million if you want, if your wallet can handle that, or if your boss will pay for it, obviously. But it's up to you. You can scale it down to bare minimum just to make system running, and then when you have a sale, you can bump it to maybe 20 just to make sure you're running. And that's exactly what performance efficiency is. Now, last one, cost optimization. It's actually what we just mentioned. Cost optimization is up to you how you're going to utilize that. Amazon gives you all the tools, including the advisory tool that we discussed yesterday, that you can see what servers are underperforming, what are overperforming, maybe where to save some money. And for once, you'll be able to have dynamic bill. It's not a fixed bill like from the data center that you keep paying the same amount of money every month, and whatever you use, or you don't use, you're still paying for it because it sits there and takes space. And in most of the time, it actually heats up the air rather than do anything really. In this case, you'll be able to fully scale up and down and make sure the cost is always the most efficient and appropriate towards the system. As I mentioned before to you guys, we managed to replace 2 or 3 servers in a simple task with Lambda, and instead of paying $1,500 a month, we actually managed to shrink it down to, as I mentioned yesterday, 0.05 US cent, which means it is efficient and it still does the same task. So it's exactly what we're talking here about. So we're going to skip to the next slide. Security. Now, apply security to all layers. Security should be thorough. For example, instead of firewalls at the edge of the infrastructure, use firewalls in other security controls of all the resources. Another example of this is using security in the EC2. Now, AWS itself gives you really good out-of-the-box security. It's up to you how you're going to use it, but it's out there. They give you option to trace all the security features and settings you have, as well as trace all the logs. They give you automated responses to security events. For example, you have an access on specific port, or someone opens specific port. What can happen is email can be generated saying, hey, actually someone opened a port on the system that is in production, and do you want to do something about it? Which means it's fully automated. You can focus on securing your system. What it means is, instead of you trying to guess what's wrong, you can actually secure it out of the box, everything, because the principle behind AWS is everything is locked, and then you're unlocking specific layers. So when you deploy a new server in AWS, all the ports by default are locked and secure. All you need to do is start opening the ports. So it's not like an open firewall straight to the internet, and then you have a problem. And also you have best security practices, which are fully automated. One of the things is exactly the advisory tool. So the one that we discussed, that will show you which ports are open. Maybe it will flag that port 22 is open to the internet, and maybe you didn't know about it. And actually have industry standards, latest reviewed principles and policies regarding all those different things. I have a question here, came from Otis. Is there a performance cost when encrypting a hard drive itself? No, it's a very good question. AWS states that there is virtually no performance itself, and that's pretty much what they will tell you. I can tell you like this: when you enable encryption, and that's a little secret from within AWS, they're running actually two different networks within. One is unencrypted, another one is encrypted, and those two networks are working fully independently. They use different switches, they use different layers, and in fact, they're using totally different topologies itself. When you encrypt your data, it will go over the encrypted network instead of the open one. And up until pretty much 2015-16, not many people were using all of those encryption features. They basically didn't know how to use it, and the security network, a secured network, was really empty. Nobody was using it, which means if you actually enabled security on all your hard drives, for example, it was much quicker sometimes to go over the secure network because it was underutilized than over normal one. So at this current stage, there is maybe 1%, maybe 2% degradation of performance, but you probably will never notice it, and it's fully managed by AWS. When you use encryption of the volume, you quite likely use a service from AWS called KMS, which is exactly to manage your keys, and everything is hardware encrypted. They have a special devices that decrypt data between EBS, for example, in this case hard drive, and the server, and everything is hardware decrypted and encrypted. So it's actually very, very quick. So I hope I answered your question this way. So AWS shared responsibility model. This is very, very important, and I really want you to understand that particular slide, because that's one of the most fundamental slides you can actually have. What AWS mentions, sorry, just let me remove my doodles. What AWS mentions, and is trying to always make it clear, is AWS is only responsible for that particular bit. What does it mean? They're responsible for compute, they're responsible for storage, they're responsible for a database and networking. Also, they're responsible for all the data centers around the world, which means it is their responsibility. of every single hardware bit you can think of. Everything that is on top of that, which we're going to discuss now, like even your encryption, basically a network, how you're going to enable encryption and integrity, OS, network and firewall configuration, platform, application, identity and access, and the most important, customer data. Everything beyond that point, it's your responsibility. AWS provides you with the hardware, with all those features, all the control panels, and everything else you want. But what sits on top of the box, it is your problem. AWS doesn't have access to any of your data, and I have to stress this. They do not have ever access to any of your hard drives. They don't have access to any of your servers. They can restart your server, that's fine, but they don't actually have any access to anything ever. And this is done on purpose to make sure that they are compliant with lots of regulations, and to make sure that the data or anything else cannot be stolen or leaked out by their own staff or anything else. And that's the biggest point that I'm trying to make here, that AWS is only responsible for hardware. I have a question from Ashok. Whose responsibility is to update the security patches on the OS? That's actually a very good question. Now, I can answer this in a simple way. There are pretty much two different scenarios you're going to have. Scenario number one, you have an EC2 box, yeah? And you're running actually on the EC2 box, maybe Windows or Linux or anything else you want. Now, the box itself, so all the hardware and everything else, belongs to AWS. They're just renting it to you. But OS itself, all the data and all the networking security or whatever you implemented on it belongs to you, which means you are physically responsible to manage your own security. In which case, you need to patch the systems, you need to update them, you need to pretty much implement anything you want. You can actually, on AWS website, there is a security bulletin that actually is very, very up to date, because AWS is very proud of their security worldwide, and the kind of leaders at this current stage. If there is any problem like a ghost shell or any other issue, security threat that you can hear about this on the TV, they are pretty much one of the first ones to implement all the fixes regarding how to do it, help you to do it. They're kind of proactive. They're trying for you to do it, but they will not do it for you, and that's the biggest advantage. Now, the second scenario is service, let's say, called RDS. RDS. Now, the RDS is a fully managed service, which means that everything on it, which means a hardware, that means OS, and that means even the database engine itself, is managed by AWS. What it means, it is fully managed and maintained and updated, patched, and everything else you can think of by AWS itself. All you need to do is specify the maintenance window when they're allowed to do that. And within this maintenance window, the box will actually go through the patching and all this stuff, which is great, because suddenly you're not responsible for any of that, which is amazing, because you don't have to spend days doing the same task over and over again, just clicking update, 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 and make sure you do it correctly. Plus, I know for sure none of you guys, no matter how many years or centuries you work in IT, you cannot know about every single security issue. The whole teams and the whole companies dedicated to this, and they don't know it all. So I would say the RDS and managed services from AWS are actually pretty awesome, because they take headache away from you when it comes to updating all of that. All you need to do is worry about the data that sits on top of that, and that's all it is, which is great. And you're only paying for this privilege. So that's the advantage. I have a question from Chandra. Is it IaaS and PaaS services? Are they I presume, are they kind of shared responsibility as well in this context? Is this correct? For those who actually don't know, IaaS itself is infrastructure as a service, and PaaS itself is a platform as a service. You can actually think of AWS as an infrastructure as a service, and PaaS as a platform. You can think of RDS, because it's actually a platform, which means it is platform as a service provided to you, which means all you need to do is just upload your data and use it. So, I mean, do we have IaaS and PaaS service in AWS? Yes, yes, we do. As I mentioned, Chandra, the IaaS itself is Amazon, if you think about it, because they provide you infrastructure as a service. You don't ever have to go to the rack or anywhere else and fill it with the hard drives. In fact, you cannot. So all the hardware, all the networking, everything else is provided by them. So virtually, AWS is a IaaS. Now regarding PaaS, you can build your own if you want on top of the AWS itself, but they provide different services like RDS, like S3, for example, which is actually a PaaS because it is dedicated platform as a service to provide specific task, which I hope I explained the question correctly. So that is very important, and AWS always stresses this out, that the shared responsibility all the way to the hardware is them. Anything on top of that, it is your responsibility. So moving to the next slide, security in the cloud. I have another question from Charanjit. If we run instance in EC2, means is it our responsibility to patch OS and hardening its security? That's absolutely correct. EC2 is nothing else as a VM, and they give you the hardware, they give you the CPU and memory you want. Anything on top of that, it's your responsibility, which means they pretty much give you empty box, and all you need to do is basically take care of OS, take care of applications, and everything that sits on top of that. So yes, you need to take care of all of that. So, security in the cloud. What we need to discuss is data protection, privilege management, infrastructure protection, and let me just close this one, sorry for a second. And detective controls. Now, data protection itself, it's up to the user. You need to make sure that your systems are protected and the data is secure. Now, AWS will give you all the networking, all the hardware, but it's entirely up to you if you're going to secure it or not. If you're going to make your service publicly available, AWS will not be responsible if someone actually goes over your SSH because you open that and breaks into your system. Now, they do have tools in place and security in place to actually be able to detect specific threads and maybe block that. They don't mention really that much because they don't want you to know it, but AWS itself is really, really protected. Second thing we have is a privilege management. It's entirely up to you who you're going to grant access to. You can have multiple users in your environment, we're going to discuss a little bit later, and it's entirely up to you what kind of privileges you will give to them. If you give them too many privileges, like I'm going to make you a full admin just because it's easy to do, and then they for some reason delete some servers because they have a right to do so, well, it's your fault, not AWS's. Infrastructure protection. They give you the ability to protect all of this with the devices like MFA, which is a multi-factor authentication, which you can have on the mobile phone, or you can have a little fob or token, and you can enable this. It's not enabled by default, but you can enable this on every single user account, which means whenever they log into the console, they will need to not only provide the username and the password, but also they need to generate a new PIN every time, or a new token or new code. And this code is only valid for, let's say, 60 seconds, which means after 60 seconds, they have to do it again if they didn't manage, which means it's extremely secure because even though some users will, for example, send email with a username and the password, and this email might be, I don't know, intercepted, or someone might, you know, steal it from your desktop, or you have maybe virus that actually went through all your files and made it public, which happens a lot. It's up to you that you can then set up MFA, and even though someone does have a username and the password, well, without MFA, they're not going to go far because they must provide this to be able to access AWS, which I would highly encourage you to do because it's probably one of the first things you want to do. And one of the last things on the list here, let me just slide this window, is detective controls. Now, AWS does give you different kind of controls. It allows you to log everything into a cloudtrail, as we discussed yesterday. It allows you to pretty much have all the view of what's going on within your systems, and it's actually great. Now, they're not going to do much about it. They're not going to tell you, hey, you have a breach, because it's entirely up to you. if you open too much security on your systems. What they will give you is ability to log it and maybe parse it somehow and link it with some sort of application that will actually flag it maybe via email, maybe will pop out on your screen that there is strange activity, and that's exactly what they give you. So let me hide this thing, and let's skip straight to the next one, data protection. So before architecting any systems, use the following practices to ensure security of that AWS account. You need to, first of all, categorize data based on sensitivity. It is very important. You might have a system that consists of a web server. You might have a system that consists of a database, and maybe there is some sort of application backend system that is running there. Obviously, web servers quite likely will be exposed to the internet, and that's the primary use for them. Now, the database itself will not, and that's a different tier. And you need to make sure that you understand and you actually draw it. So, for example, you have non-sensitive data here, and that is exposed to the internet. And behind that, you have a database, and then you have additional layer if you want, and you have application server that actually does some sort of magical operations on the database and generates reports. And that particular layer here is exposed to the internet, but that one here is not, which means it cannot be accessed directly from the internet. But you can then access different rules that will allow those boxes just and those boxes connect to the database, but nothing else, which means the internet cannot access any of your systems, which is actually great. And the same applies to the backend box here, because there are multiple tiers and levels that you can set up later on with security groups and different permissions. You'll be able to do it without any problem. I have a question from Ravi Babu regarding by default user has all these authentications. Yes, every single user, and I'm going to show you this again later when we're going to be doing it hands-on, will have access to all of those security that we just mentioned. It's not enabled. You have to tick the box and you need to set up your MFA device, either token or a software one. But it is not enabled. And AWS does give you all those features, and it's entirely up to you, and it's your responsibility to actually make it happen. Last thing on this particular slide is a grant list privilege. As I mentioned before, I've seen this multiple times, and quite likely I will always see it in the future. What people do when they start with AWS is they grant permissions, and usually when they grant permissions to themselves, they grant pretty much full admin because it's any other one is too restrictive, which throws you lots of errors, doesn't allow you to do many things. So to make your life easier, lots of people do that. And then the new person starts, and you give them the same permissions just because it's easy. Now, it's entirely up to you how you're going to do this. I would advise you to grant a least amount of privilege to every single person, especially when they never worked with AWS. I've seen this so many times. Someone tried to delete one environment or one server for an environment, and what they've done is deleted the whole environment in production by mistake because they didn't understand how this works, and the whole system went down. And obviously, you can blame the person to do that, but it was actually your own fault that you granted them that much permissions, and you didn't make sure that they're aware of what they're doing. I've even seen lots of very advanced system administrators and cloud guys. After working a whole day of like 12 hours, let's say, you're extremely tired. You don't even know your name, and then you're responsible for maybe deploying something new or deleting something old. And because you're tired, you have no idea what time it is. You just basically click on random stuff without thinking, and you just drop the whole environment. And even to yourself, you can grant different levels of privileges. You can, for example, restrict yourself from production that you can only maybe read, so you can see it, but you cannot touch it. And that means that in the future, if you ever make a mistake, well, mistake will not go through because of your own permissions are restricted, which is actually a great idea, and it makes the whole system much more stable because you're not going to drop the whole production environment just like that. So, data protection. In the data protection itself, we have multiple different tiers, as I mentioned this before. We have encrypt and manage data, and there are services like IAM or KMS. Today we'll be talking quite likely about IAM. We will also mention KMS I think in today's session I'll need to check that. We also have cloudtrail. What cloudtrail is, it's logging every single action on AWS console and API, which means it can be traced back to an individual or a system. We also have make use of resilient storage systems like S3. Now, that is very important. As I mentioned this before, and I will say this quite likely again, AWS S3 has 11 nines of durability. What it means is, if you think about 99.9%, that's a lot. But actually, AWS does have 9, 9, 9, and there are actually 11 of those behind. What it means is if you store 10,000 objects with AWS, let me just hide this for a second. If you store 10,000 objects with AWS S3, you can, on average, expect, to incur a loss of a single object once every 10 million years. That's correct. If you ever upload 10,000 objects, AWS is capable of losing one file in 10 million years. That's actually, I've never seen such numbers. If anyone ever, any provider gives you a uptime of something like a 99.9, that's awesome. Most of the production systems that I've seen running, actually maybe 98, 97, good ones maybe 99 just about, but not 99.119. That actually never happened. And they do have to say this because obviously it's only hardware, but the way they replicate the stuff across multiple data centers is extremely, extremely good. And AWS itself is proud that the data protection they have is such a durable service. One of the last things is also use a versioning and lifecycle of S3, which means that you can enable this by simply clicking on this, and I'm going to show you later on as well how to do it. Enable versioning, which means every single file that overrides the previous one, it's kept in a history. It's basically like a Git or any other versioning tool that allows you to keep all the files, which means if someone reads the file by mistake or overwrites this with some sort of a newer version, guess what? It doesn't really matter. Yes, the newest version will be the only one visible to the user, but if you look into the console, you can actually restore any version of the file before, which means you never lose the file. The downside of that, you have to pay for all the versions out there because they are kept as individual files under the same pretty much name, but in a different version. But guess what? AWS S3 is so cheap that probably you'll never even see S3 on your bill because it's so cheap. So let me go to the next slide, if okay. Privilege management. It's a central part of an information security and security program to ensure only authorized and authenticated users access your resources in the way that is acceptable to ensure compliance and use. What it actually means is you're responsible for granting privileges to the users. If you think about AWS, think of it as pretty much Active Directory. When in Active Directory you have a user and create a new one, you can grant them pretty much all admin rights if you want to. If you really that crazy and you want them to do pretty much everything, including maybe even deleting the Active Directory server itself, because that's what admin can do. But most of the time when you work for bigger companies, everyone is restricted to a bare minimum amount of permissions, and it's up to the user, like an admin or system admin or anyone who manages AD, to make sure that people cannot go beyond and above. Maybe you have some regulations in the company saying, you know what, we have users that should not be able to access this resource because they're not cleared. Maybe there is some sort of secret data on your systems. Like maybe good idea is maybe working for a financial firm and they have a data on the system that, if leaked, could actually lead to a huge financial instability on the markets. And you don't want everyone to just access this. And there's this very famous case of Mr. Snowden, as you probably know. So the whistleblower from US that took lots of secret documents around the world and basically made it public. And if you think about it, Well, yes, he did a bad thing from one side, but lots of people think he did the good side, the good thing. And I'm not gonna really choose a side at this kind of stage because it's not my place to do so. But you can prevent this kind of behavior by applying proper privileges and making sure that people have only the rights they need. And if they need new rights because they want to go a little bit beyond and above, at least they need to ask for it someone like you or someone else in your company, and it can be reviewed. And for example, if someone asks, hey, can I have access to all your files and all the S3 on all the buckets? The first question should be, why do you need that? What are you trying to do? And maybe they need only access to one bucket, but they don't know. They just want access to everything, and it's very good. So I would highly encourage you all guys to make sure you review the privileges of all the users, always very close, and make sure that nobody is using more than they really need. We can use in here a few things. We can use access control list for that, which is also known as the ACL, and I'm gonna show you this later. We can use the role-based access controls as well as password management, and I'm gonna discuss this in detail in the next few slides, hopefully today. So, infrastructure protection. Basically, to meet the best practices and industry or maybe regulations that you have in your country or your company, using multiple layers of defense and multi-factor authentication in all the types of environment is sometimes a must. And usually when you work for a big company, they do have a multiple tiers of security. They will have front-facing firewalls. They will have mid-facing firewalls between the internet and the gray zone, or like DMZ. Then they will have internal firewalls for different systems between the file servers and different things. And all of those different tiers can be pretty much replicated on AWS infrastructure itself. So MFA is one of those things that allows you to authenticate with additional protection, but also, sorry for that, but also you can implement VPC that we discussed before, which is your virtual private container, which actually only specific systems within will be able to talk to each other. Anything from outside, unless you really want that, cannot communicate with this in any way. And also you have additional tools like cloudtrail and Cloudwatch that actually log, monitor, and alert if any of that particular behavior happens. So AWS gives you all the tools and all the settings you really want to use, and it's up to you how you're gonna use them. So that's the biggest advantage. Next one, detective controls. I see a question from Umesh regarding what is stateful and what is stateless. It's a very good question, and we're actually gonna discuss this exactly when we will be talking about in the previous slide, when we're gonna be talking about types of security we have. We have security groups, and we have knuckles, so-called. One is stateless, and one is stateful, and we're gonna say exactly why we call them like that and when we use both. So I will come back to you on that when we're gonna be discussing this in a great detail later. So we have detective controls. In here we have you can use detective controls to detect or identify any potential security breach, or both, maybe for quality support process or compliance reasons. A few of the detective controls are AWS Cloudtrail, which is a web-based service. Let me skip, sorry, yes, here. Let me just select that. We have AWS Cloudtrail, which allows you to log all the API calls of every single activity in a whole entire account. Yes, Cloudtrail itself you need to enable for every single region separate, because it's logged into the S3 bucket from where you can take those logs and you can then parse and process them whichever way you want. But it allows you to actually log whole entire environment with pretty much a single click, and it will start creating those logs and populating them if there's any activity. Second one is a Cloudwatch. Cloudwatch monitors the AWS resources, as we discussed yesterday, like hard drives, network activity, databases, and volumes, and it actually gives you stats. Now, it is not used to create logs, but what it can do is give you charts and potential issues. Like, let's say you have a system that is running hot because you have a sale. Cloudwatch itself can actually be used to generate maybe a alert if any of your systems go beyond 80% of CPU, or maybe if the network activity spikes for some reason, it will be able to alert you about that, which is actually very, very good. Next one is find about configurations and changes in infrastructure, so-called AWS Config. What it is if you deploy environment, something like a production-grade environment, what you'll be able to do, you will be able to pretty much save this in this particular time. And if any change in the future occurs because someone logged on and changed maybe a single security group, or someone added maybe additional server that or maybe someone removed the server, you will basically be straight away notified about that. And it's exactly great because you can make sure the environment that you deployed is exactly what you agreed. Maybe you have some sort of documentation of it, and obviously the last thing you want to do is someone to log in and start changing stuff while you actually agreed through multiple cabs or any other process in your company that this is exactly what it is. Also, you can make sure that the system you're running is exactly the same as system that is, for example, QA, so quality assurance, that when guys are testing the systems, they're testing exactly the same infrastructure and the same setup, and it's actually used for that. Another thing is AWS S3, and it can record all the details of access requests. What you can do is there's a little tick box, basically log all activity on S3, which means every single file from every single bucket can always be logged as someone read it, someone changed it, someone updated it, or any other action, which is great because suddenly you have a control of actually auditing what people within your company are doing, which most of the time you have no idea. Imagine you have a Windows box which acts as a web server, sorry, not web server, a file server, and people are accessing it. People are, using it. Yes, you can enable additional logging on it, and trust me, it is a nightmare. I've been there, I've done that. It's not pretty and it's difficult to do. And what you do here is you tick the box, and the whole job is done. It actually logs all the activity. Let me just minimize this particular thing. Sorry for that. Now, one of the last features of detected controls is that you can use a vault log feature to preserve critical data in the Glacier. What it means is, imagine you have recently I actually worked for the financial company, and I was responsible to do a storage system for all of their trading and all of the information, pretty much every single activity within the whole organization. And the organization was pretty big. They had over 50,000 people worldwide. Now, because of the regulation states that they must keep their all activity in a safe place that cannot be changed, to meet this regulation, they had a huge rack full of basically storage devices that were basically logging all of this from the entire world in a single place in UK, and they have to keep it. And funny enough, they have to keep it for 7 years, and also they need to make sure that no data is actually changed, updated, or removed for up to 7 years, and that's a regulation. If they don't have this, they will have lots of problems. And the problem was that this particular system they were using, the old-fashioned system, was actually failing, and it was so old that they had an issue and they had to comply with lots of regulations. What it means is we actually deployed a new solution based on a Lambda, and what we introduced is so-called a vault lock, which means we created a simple policy saying you can upload stuff here, that's fine, but you cannot delete anything for up to 7 years, which means every single object or a file in this case that was ever uploaded to the Glacier itself had a policy saying, you know what, this particular file will not ever, and by ever I mean 7 years, be removed, changed, or modified in any way. Even if you try, you can't. This file will be persistent for 7 years. Yes, obviously, if you delete the whole account, like terminate the whole AWS account, the data will be erased. Don't get me wrong, yes. But for as long as you're paying for the account, that particular policy works, which means it's a compliance. So So there you go. We can skip to the next slide regarding reliability. So in here, Amazon defines reliability as ability of the system to recover from infrastructure or service failures, dynamically acquire computing resources to meet demand, and mitigate disruptions such as misconfiguration and transient network issues. What it means, I mentioned to you guys before, and I will quite likely say it a few more times. We all know that AWS works on many, many hundreds of thousands servers, and they quite likely not the best. The reason why they can achieve such a huge uptimes is because they do not keep data in one place. They keep it replicated across multiple systems in the same time in multiple data centers. And this is how it works. And I noticed that really with AWS itself, once you actually have data there, there's quite likely no need for you to back it up, because once you actually put data in S3, if you lose a single file out of 10,000 files we uploaded every 10 million years, guess what? That's good enough to me. I've seen magnetic tapes of the backup systems going really bad after a week or two because someone kept them next to the heater, or maybe they were in a dump and you cannot read them. And what kind of backup is it if the tape itself cannot be restored because it was in a little bit humid environment and it stopped working? And with AWS, you can make sure that all your files will be pretty much accessible whenever you need. So pretty much that's from this particular section. So also regarding the subject, you can test recovery procedures, which means if you ever upload anything to AWS and you want to recover it, guess what? You can. You don't need to run for any tapes. You don't need to bring lots of different hard drives. You actually can recover everything you uploaded by basically downloading it again and making sure the data is intact. And in fact, there are sometimes regulations stating that once a year, for example, you must test random files, and they give you, let's say, 20 different files from a batch that you must download, open, and make sure it's not corrupted. And I can show you we've done this multiple times. You can set it up in an automated fashion, and it's very, very good. Another one, automatically recover from failure. What it means is when you, for example, have EC2 instance and EC2 instance failed, went dead, what it means is AWS straight away will give you ability or automatically launch another instance and take the data from a faulty instance, which wasn't really sitting here, it was sitting on the network drive anyway, and attach it to this one, which means you can just basically restart the faulty one or boot up the new one, and the server will be exactly in the way that the previous one stopped. Guess what? Try to do this in the normal on-prem with the hardware if possible. Well, you can't. If you ever worked with the VMware, you pretty much know what I'm talking about, because you can kind of achieve the same thing. You can have a single VM, and for example, you can use iSCSI attached drive, and if this server fails, you can basically create a duplicate of that and attach the iSCSI to the new box, and off you go. It's pretty much the same in AWS, with the exception of it's much more simpler than VMware itself. It's basically, in most cases, you can enable self-healing or auto-recovery as well, and it will happen behind the scene automatically. All probably you will notice is the box will restart, which most of the time is not a big problem, especially when you have multiple boxes in a system designed to a full, full uptime, and at least have two boxes in production to make sure that in case one goes down, other one can take over, and both of them are working fine. Another point is you can scale horizontally to increase availability, and that's important one. Imagine, I'm gonna remove that and I'm gonna draw here. Imagine you have ELB here and you have internet on top. Traffic comes to ELB. That on its own is almost a bulletproof solution. It's a fully managed service that is a load balancer in front, and then you have 2 or maybe 3 boxes just for fun, because you can have, and the traffic flows to all 3 boxes. Now, that's great, but imagine suddenly someone comes to you and says, hey, actually, you know what? We are going to double the amount of traffic we're going to have towards those boxes because there's a sale, or maybe because we have more customers, or maybe because we've done some marketing, a mail that everyone now will be coming. Guess what? What you can do is to take a copy of this particular box, add additional ones, and basically ask ELB to start serving the traffic. And what we call it is horizontal, because you can have almost unlimited number of boxes behind ELB, and you scale horizontally rather than vertically, which is exactly what you're trying to do. And it's actually a very, very good solution, and it's one of the most common cases that you will always use on AWS. And AWS was actually designed for that, so it's exactly what we are trying to do. One of the last things on this particular slide is stop guessing capacity. Exactly what we mentioned. You don't need to guess it. You deploy 2 boxes, and if it's not enough, you deploy a 3rd one. If it's too much, you delete. And basically, you always keep, which means you don't need to over-provision. You don't need to order more hardware than you need, and then the hardware sits on the shelf and it's not used. Because most of the time, when you have a servers or anything like this on your rack shelf or anywhere else, you most of the time will over-provision this on purpose just because you want to have more capacity that you need. But in this case, you only provision whatever you need, and if you need to go further, you go beyond. If you need to go below, you scale down, and that's the benefit of AWS itself. I have a few questions here. When we refer to a dead instance, is it an EC2 instance or S3 instance? Okay, that's a very, very good question, Omkar. I'm going to explain like this. EC2 instance is like a server, and potentially it's like if you ever worked with a VMware, it's basically like a VM itself. So it's allocated amount of hardware on the bigger box that is given to you for you to use. And we only say a dead instance in case of EC2 because S3 doesn't have instances. S3 is a service that you basically upload all your files, and that's the biggest difference. So I hope I answered this question to you. Another question from Charanjit: which one are iSCSI and SAN storage in AWS? Now, to be honest, AWS doesn't provide any information about their infrastructure. As I said this before, even the people that work in AWS, and I know quite a few of them, do not know what AWS consists of. It's actually a secret. It's a guarded secret that if everyone would know, probably they wouldn't like AWS as much. But because how AWS is built and the way it's built, because it's a secret, everyone thinks it's amazing cloud, which it is. But behind all of this, they're just normal servers like you would have on your shelf. Behind all of this is normal networking equipment that you would have in your office. I wouldn't really go as far as unmanaged switches and all of this with maybe like crappy cables. No, I would go far away from that. They still use state-of-art networking and cabling, all of that, just to make sure that it's extremely stable. But it is a secret. I can tell you that EBS, for example, volume that you can attach, so it's a kind of network drive that you're attaching to your instance. I presume it's an iSCSI, but don't take my comment as a stable answer, because we're only guessing. It acts like an iSCSI, it behaves like iSCSI, the network traffic and everything else, and also block level storage that we have, it acts like a SCSI rather than a SAN, because we can take this instance and move it somewhere else, and you can reattach it, and it's easy. So it kind of behaves like an iSCSI, more or less. Now, we are in AWS itself, and I'm going to be showing you all of that more and more as we go along. And what I'm going to do is I'm going to go to Services, I'm going to go to EC2, under the Compute, and in here, I'm going to show you limits. You can read about this a lot on the AWS. By default, AWS will give you a limit of 20 servers for any type. And obviously, the bigger the boxes, less they want you to have. Now, it's not a fixed limit. You can always increase, increase if you want to, and you can virtually. There is physically no limit to how many boxes you can have. I know environment that we're running around 15,000 servers in a single account, which is great because it's a massive environment. But I noticed that maybe it's easier sometimes to split your whole environment between multiple accounts for redundancy or for any other reason. And I will be able to give you some examples in the future about that as well, which are actually valid. So physically, there's no limit, but you will need to ask AWS via the physical, via the ticket or request. Hey, I need my maybe a C1 extra large instance to be increased from 20 to something like a 50 because we have a sale and we need more of those. And AWS will come back to you within a matter of minutes and say, there you go for it. All they do is basically validate that you are not some sort of a DDoS hacker that is trying to basically spin up hundreds of thousands of instances and attack any website. And this is how they defend against that. You physically still need to send a reasonable increase. If you, for example, will go to them and say, hey, from 20, can I have 20,000? They're going to say, actually, no, because we don't have a history of your account and we don't really know what it is. So when you have a new account, maybe the increase from 20 to 50 is reasonable. Anything beyond maybe 100, they will ask additional questions, which exactly is the point of this whole thing. So I hope I answered your question. I have another question. How much instances we can run in EC2? Is there a limit of rate instances on EC? So I hope I really explained that virtually there's no limit on the account. There is a soft limit, so-called, that you can increase at any given time. So coming back to the presentation itself. So let's, another question from Gabriel. Will it automatically spin up more instances based on the traffic detected by ELB, or should we specify it? Now, ELB by itself will not add any extra instances. All it does, it routes the traffic that comes in between all the boxes or all the instances that you're currently running behind it. If you want to auto add more instances, you will use a service called auto scaling in conjunction with ELB itself, and I will discuss this with you exactly later. What it means, you will specify a minimum and a maximum amount of servers and specific thresholds. Let's say if the load goes beyond 60%, add 2 extra boxes, or if the load goes beyond below, let's say 30% of CPU, then remove 2 boxes, but always keep a minimum amount of boxes of, let's say, 3, which is exactly what you're trying to achieve. And that will allow you to do automatically going up and down. And not only you will save money by that, but also you can guarantee that human-free interaction can actually spin up and down an environment just to accommodate the traffic. I have another question from Otis. Will we see more of AWS like you, or demo for hands-on training? I will be more than happy, and I really want to show you as much as possible from AWS console and how to do lots of things, which in my opinion actually gives you the best result, because you need to understand all of this. And obviously that's a kind of a little bit of dry knowledge we're trying to pass right now, but I'm giving you all those examples from the real life, and I really hope that all of those examples, you can imagine how more or less it works, and you get better understanding and quicker understanding of actually how specific concepts are working. So I would say I will give you much more hands-on as well as we go along. So let me skip to the next slide. Basically, how reliable is the cloud? We can actually say that there are foundations, change management, and failure management. Foundations are all the operations that you can do that will make your application stable. And from AWS perspective, all the foundations is that they provide you a hardware and redundancy in any way possible. So all your systems that you're currently running are maximized for full uptime. Change management is entirely up to you. You deploy the application, you deploy all the changes, and it's entirely up to you how you're gonna do it. Now AWS does give you a little bit of head start on that. You can create AMIs of your instances, which means the copies, and you can change that, and you can redeploy from the new one, so you have exactly the same change management. And also they give you ability to restrict via the permissions users that are performing certain changes, and that's the change management really. And then failure management is they give you all the tools, and like Cloudwatch, for example, or cloudtrail, that you can actually see whenever something failed or is about to fail, or maybe something did fail, and then you can go back into logs and see what exactly happened, and you can investigate that. You can communicate with AWS very well. You can use their support. It's very good. I actually worked with AWS for 7 years now, and I worked closely with AWS teams. Their knowledge is extremely good. I can assure you of that. If you have a problem, quite likely they had it before, and they will point you towards the right direction. They will give you all the documentation you need. They will actually explain a little bit. What they will not do, and that's important to remember, is that they will not do stuff for you. Despite the fact AWS is a managed service, as a whole platform, everything that sits on top, as we discussed before, it's your responsibility. So they will give you a really good articles and point you to maybe forums or articles that explain how to fix this issue, but they will not do it for you. I have another question from Charanjit Sebastian. If the load reaches above threshold, and if we set out auto-scaling, for instances, will ELB learn how new instances are removed and added? Yes. And the service that we discussed before, called auto-scaling, fully integrates with ELB, which means if it says, I need more instances because there is a spike of traffic, it will spin up those instances, basically will provision them for you. It will add, make sure that they're up and running, and it will join automatically ELB pool. Now, what ELB will do is you set up so-called health checks, which means if, for example, every few seconds, the machine itself, sorry, the ELB will try to ping this box and try to access a specific link. If it cannot access a specific link, that means the box is not ready. Up until the stage it can. Once it can, it will add it correctly and then start serving the traffic automatically to this particular box, which is exactly the behavior. The same applies when the box actually goes down and something actually application maybe stopped working, something, I don't know, software, maybe hard drive ran out of space and the whole system just went down. What will happen is auto-scaling itself via the health check will detect, oh, actually I cannot access this box, and it will stop serving traffic to the box instantly, and it will show you that there's a failure. What it means, it will not remove this box from a pool, but what it will do, it will not serve any new traffic, and it's entirely up to you what you want to do. Maybe you want to jump on the box, and maybe you want to find what was the problem, which is entirely fine. But auto-scaling can be set up in the way that if the failure is detected, it will remove the faulty box and it will replace the box with a new one to start serving traffic. So such options are available. So I hope I answered your question. Okay, I have a follow-up question from Charanjit, which is how we determine the new instances and how do we get IPs, host names. Now, it's a very good and valid question. When you think of a cloud, we don't really think of static IPs anymore. We don't think about, we can think of host names, but we don't tend to. The reason is, when you're using auto-scaling itself, the load balancer doesn't care what's the IP of the box itself. It's actually integrated within, it integrates with the EC2 itself, and basically via the API, it joins this particular instance into the pool of ELB. So you don't need to set up anything. You don't need to guess the IPs. Most of the time, in fact, 99% of the time, all our systems that I ever run are on the dynamic IPs. Nobody cares what the IP is, because if the box goes down, the new one will come over and join the pool. So you don't care about either IPs or host names. Everything is integrated within the system. I hope I answered, and I will be able to give you more examples of that in the future when we're going to be discussing exactly this behavior. Let me skip to the next one. Foundations. So before we are taking all the systems foundations that impact how stable and reliable system is, must be in place. So important things, sufficient, oh my goodness, what a big blob we have. Let me remove that. I'm not sure why it's changing, but hopefully we'll make it nicer. Sufficient bandwidth. That's the important bit. Sufficient bandwidth itself is important. Now, EC2 and systems and boxes can have different amount of bandwidth available. Imagine if you buy an extremely small box, and I can show you this on the on here. If we're going to type in Google AWS instance types, one of the nice websites that I use pretty much all the time, it's funny enough not the AWS one, is ec2instance.info. I'm going to show you how it works. Now you have multiple instances, and all of that is pretty much live, which means you can see different types. You can see how much memory you have, how many CPU, basically how many units, storage, and all of this, as well as network performance. So imagine I'm going to tick lots of them just because I can, and I'm going to choose something like a T2 Nano. This particular one, I'll highlight this for you guys. Let me just do this. This particular one gives you network performance low. Wow, this doesn't define really what it is. Is it like 10 megabits? Is it 100 megabits? Sorry, increase the font size. Yep, can do. Sorry for that. I hope that's big enough. So the instance, sorry for that. There you go, drawing tool. The instance that we're talking about has T2 Nano, has a low network performance. Well, it costs a little because it's really, really cheap. In fact, if you spin up this on your environment, quite likely it will be for free because Amazon gives you this free tier. And what it means, they do not specify how much network bandwidth it is. They say low. We kind of know that low is around maybe between 10 and 20 megabits per second, but it can vary. It's a cloud environment, it's a shared environment. Sometimes you will get 20, sometimes you will get 10, and it doesn't really say how much. Now, if you're gonna go for anything bigger than that, so if I'm gonna go for maybe M4 large, suddenly we jump to a moderate. What it means is that we have much more bandwidth than low, that's for sure, but they still don't tell you how much. And we know that the bandwidth will not go below certain numbers. And obviously, bigger the box you will get, so imagine maybe something like an M4 extra whatever, 16, it will give you 20 gigabits of bandwidth. Now they do tell you that because they want to make sure you understand. And sometimes when I'm going to go back to the course, let me just quickly click. So sometimes when you're deploying the different applications, make sure that CPU is not the only thing you're looking at, because you'll be surprised that sometimes you might saturate the whole system because you are actually pushing all the traffic via a very small trunk, especially on the network that we don't really know. Another one is sufficient compute capacity, which means basically a CPU and other things. I can go back to my chart here, and I'll be able to show you. We know as a fact that capacity probably means ECU or CPU, as well as the memory itself. Every single instance will have a different kind of types, which means no matter what instance you would choose, you can accommodate exactly what you're looking for. So make sure you always understand how much resources you need, as well as obviously over the time. What is ECU? We have a question from Chandra. That's actually a very good question. What ECU is an elastic compute unit, and think of it like that. AWS specified that a single ECU unit is worth more or less 1 gigahertz of compute power. Now, what it means is that, for example, if we have a box, something like a, I'm going to choose some small one on purpose. It's burstable, so it's not invisible here. Let's say we have a box, something like 8 units. That means that 8 units times 1 gigahertz more or less will give you performance of around 8 gigahertz performance. Now, if you think about having maybe like an Intel Core Xeon processor in your server that is maybe quad core, and you have a 2 gigahertz per per core. That exactly gives you 4 times the 4 times 2, it gives you 8 gigahertz. So more or less, this is what it is. But what in this case is, it gives you 8 gigahertz of performance, more or less, and it shows as a 2 virtual CPUs on your task management. And this is exactly what you will get. So make sure you understand more or less how much capacity you need and plan ahead, because it's going to be easier for you to plan and deploy the systems that are more or less what needs to handle. Another thing is, let me just increase the blob size, is trained staff. That's very important. Make sure that the people that deploying applications and deploying the systems in AWS fully understand and they're trained to accommodate the required performance and components of every single system. Make sure that people are aware of the latest technologies as well as the latest instance types, because AWS constantly comes up with the new ones. Different sizes is one thing, but they also have a different architecture. They have instances that are based. I will get to all of this in the future once we're going to start discussing C2. But just to give you a rough idea, they have an instance type C, which actually stands for the compute power, which means they give you more CPU, but they take away a memory. They have a memory base, so M is actually not memory based. M is actually universal. Will give you a good balance between CPU and will give you a good balance between memory. You have a storage I type instances, which will give you kind of okay balance on memory and CPU, but what they will give you is a huge amount of storage as well as the good performance for the storage. So if you need to track through lots of logs or have very I/O intensive applications, you quite likely want to choose them because you know that you are guaranteed the good performance between those two. So one of the last ones is support contracts. Now, there are a few levels. By default, you're on the free support contract. It's okay. It doesn't really give you any perks or benefits, and I'm gonna give you a breakdown of that as we go along in the future. Personally, I worked pretty much through all different support contracts, all the way to enterprise, which by the way costs $10,000 a month. Yep, that's the cost. Or whichever is greater, which means if your systems, for example, cost £1 million a month, then they take 10% of the system, and whichever is greater, you have to pay that one. So I will explain this exactly to you in the next few slides because we're going to be getting there very, very soon. I have a question from Charanjit regarding what is T2 micro / nano instance. Is this regarding the CPU and performance, Charanjit? I presume it is. I'm still waiting for Charanjit to reply, but I can actually show you this. Basically, T2 instance type is a very, very interesting instance, and it's a little bit scary instance to use, and I'm going to explain why. You can see here from a CPU compute unit that is a burstable ECU. And what does it mean? Well, it doesn't specify how many gigahertz of power I have, right? Well, it doesn't, but what it does specify is number of virtual CPUs you have. Now, what AWS came up with is an ingenious idea that they can give you a T2 type instance, and what they do is when you don't use the instance, you basically gain credits for CPU, which means over time, if you don't use it, you're actually getting more and more credits. And then you can actually use those credits when you have a very task-intensive operations that probably happen maybe once or twice overnight, and then you basically burn through them. What happens when you burn through completely? Well, it gives you a kind of low performance, but it's a stable low performance. If you have lots of credits because you build them over, let's say, whole day, and you want to burn them through the night, you then basically run all those operations you want, and it will go burst into like extremely powerful box all the way up to pretty much, I think, 1, 2, or 3, or even 4 gigahertz of power, and it will process that while burning the credits. I will get to the credits in the future. I just wanted to mention this right now, especially when we're going to be discussing EC2, and there is a whole section about that as well. So no worries about it if you don't really understand it at the moment. I will show you all of this in the future slides. So let me go back to our presentation. Change management. Basically, all you need to remember is be aware of how change affects the system and that are basically allowed to you. So you need to plan proactively, which means that you need to make sure that people don't have permissions that are overblown, that can destroy production environments. And you need to monitor, make sure you monitor all the systems. You need to monitor all the systems, which means that you are aware that production system is up and running, and also automate responses to KPIs, which means that you can basically automate specific tasks, and all the actions can be fully automated and can be, for example, emailed to you. That is very important. Let me go further. And then we have failure management. Now, what I'm going to do is like this. So in failure management, a key to managing failure is the frequent and automated testing of the systems for failure and thorough recovery that enables basically that enables the cloud to be recovered. Basically, think of it like that. Temporary copies of all your systems to verify launch temporary copies of all your systems to verify recovery processes. That is very important. You have ability to copy the whole systems across and make sure that they are fully working, as well as you have a full access to copy all the files from, let's say, S3 to make sure they are valid and they're not corrupted. So make sure once in a while you run a copy to make sure that all the data is intact. To be honest, I worked with AWS for quite a while, and I can tell you that whatever we ever uploaded to AWS, as far as it was not corrupted on our end before we sent it, was actually never corrupted on AWS, which doesn't mean that's the case for everyone. I was maybe just lucky, but amount of systems I worked with and amount of companies I've worked with can determine that it's not very likely that it will happen. Another one is set up automation to react to monitoring data in case of failure. It's very important. We use this system called Cloudwatch. We can set up specific thresholds, we can specific rules saying, hey, you know what, if a CPU on my server, any server within my whole environment goes beyond, I don't know, 75% for more than 5 minutes, maybe actually email me about that, or email the whole group, or initiate specific task, and you can pretty much specify what task you want, maybe add extra resources. Another thing is store all your data for future use in the AWS 3. As we discussed, S3 is extremely bulletproof solution that stores all your data, and it's extremely good place. It's very unlikely that any file from S3 will ever get corrupted or disappear. Never happened to me, and I've never seen anything like this happening, and heard from anyone about that. And again, you can set up a versioning, or you can also set up a Glacier later on to make sure that all your data is double protected. So, going to the next slide. Performance and efficiency. Amazon defines performance efficiency as the ability to use computing resources efficiently to meet system requirements, to maintain that efficiency as demand change, as technology evolve. Now, because Amazon is extremely elastic environment, and elasticity is something you're going to hear a lot. In fact, if you think about it, every other service that you can think of AWS, everything is elastic. So EC2, for example, stands for Elastic Cloud Compute, which already has elasticity in it. So there are lots of other systems that will have E in front. In fact, lots of services will have Elastic or any other name, and they're very famous for it. So let's go and discuss more features about that. AWS provides products such as NoSQL and media transcoding, machine learning as a service, which increases performance efficiency and allows you to Let me take the drawing tool. Democratize advanced technologies. Now, what you can do is you can utilize Amazon services to basically outsource any other technology out there, which is amazing because it's extremely advanced and it's fully managed. Go global in minutes. What it means, you can actually have a whole entire environment being created in an automated fashion from maybe your QA or maybe other system, and in a matter of minutes. All you need to do is basically deploy the same template you deployed for QA, and maybe 20 minutes later, if the environment is big, you're going to have everything up and running. And guess what? Suddenly someone comes to you and says, hey, you know what, I need the same copy of the system in another country. Can we do this? And you say, sure, we can. You can take the same the template that you deployed, switch the zone, and basically deploy the same systems in other countries straight away. And that's a global in minutes. What we also have is use serverless architecture. Well, AWS doesn't only consist of a physical servers that you can use. You can also use services like Lambda, which we discussed a little bit yesterday, which allow you to perform any code operations on the serverless environment. Yes, well, behind it's not really serverless. It still kind of operates on some sort of hardware. You just don't know about it, and you're not responsible. All you need to do is upload your code to a Lambda and say execute, and you'll be in charge only for what it does, not for actually having a server, which in many cases is awesome, because if you think about it, you do not need to maintain any of that anymore. So all this useless time wasted on maintaining all those physical boxes is actually released to you, and you can actually do much cooler stuff. And also, one of the other features is that you can experiment often. Guess what? I can take a copy of my environment, I can actually copy it somewhere else, call it QA, or I can call it dev or whatever, and I can experiment with it. I can actually change instant types on my copy. I can maybe to see if it's you know, performance is awesome. I can change the maybe database behind it to make sure that it can work with a different type of database. So it's entirely up to you how often you want to do. Funny enough, once you start using serverless technologies, you will have much more time to experiment, and that's where the advantage of this is. So let's skip to the next question. Next slide in this case. Performance efficiency in the cloud. So, 1 second. So, as we all know, AWS provides products such as NoSQL and databases that we actually discussed. But they also provide performance efficiency in the services like compute, like storage, database, and space-time trade-off. What it means is we can actually go right now to all of them, and I'll discuss exactly in the detail what every single of them mean, because I'll quite like to repeat myself if we do it now. In the compute, finding the optimal server configuration sometimes, or amount of RAM and an amount of CPU that you require, can be a little bit challenging, and AWS gives you optimal server configuration for the product in the cloud that can be based on the application design. Maybe you have some sort of different usage patterns, or maybe configuration settings. Additional IT infrastructure can involve estimating in advance that can lead to incorrect server configurations and lower performance efficiency. So basically, AWS allows you to scale down and up, so increase the server size and obviously compute allocated with it, and that's a horizontal scale because you're making boxes bigger, or you can make more boxes, which is actually vertical, and it's entirely up to you. It's entirely up to the user. If you want to make boxes bigger, that's fine. If you want to make more of them, that is fine as well. It is entirely up to you. I have a question regarding can we run SAP code on Lambda? I cannot answer this question because I simply don't know. That depends on the code. If you will go to the AWS website and actually go into the Lambda section, you can see what languages actually Lambda supports, and you'll be able to see if actually supports anything from SAP itself. I never seen SAP running on Lambda, but maybe because the SAP itself is its own environment. but I'm sure it will be integrated very soon if it's not already in a so small portion. I have another question: where does the code sit without an instance? If this is regarding the Lambda itself, I can tell you that when you upload the code to Lambda, the code itself behind the scene sits on the S3. You just don't know about it, and you don't see it in your S3 bucket. It's a special place in the S3 that AWS creates for you, which is invisible to user. It's only visible through Lambda, and you'll be able to see all of this in there. But behind the scene, it sits on S3. So, so there you go. A few more questions I see. Let me see. What it means by allows you to execute code without running an instance. Okay, that's actually very good question. Imagine situation, and I want to explain. I want to explain the concept of Lambda here a little bit, if I may. If you have EC2 instance, then this particular instance will have a hard drive, and then normally you would put a code here, yeah? And then you will execute any operation to execute your code from your hard drive. So in theory, it sits on the hard drive itself. Now, when it comes to Lambda, it is not a physical box. Lambda is a service that takes the file that sits quite likely somewhere in a Lambda repository behind the scene. Quite likely is a S3, but we don't know that because Lambda or AWS doesn't say any of that. And whenever you want to run your code, you basically initiate Lambda that will basically take your function and run and outputs data or does whatever you program it to do. And you only pay for the amount of time it spent and the amount of resources it computed in order to execute your code. So it physically doesn't sit on the hard drive like here that we know. Yes, probably somewhere behind the scene on S3 it does sit on the drive, but it is invisible to us, and I wouldn't really worry where it sits. We all know it's secured and it's only available to your account. That's all I can tell you right now. That means that you don't reserve an instance. That's correct. That's correct. The beauty of Lambda is that you don't need to provision resource for like in EC2. So you don't need a server anymore that you occasionally run the code against. All you can do is actually upload your code to a Lambda, and then whenever you need to execute it, you push a button, and it does all the processing automatically behind the scene. So yes, some sort of resource is allocated to you for the specific time, but that's all it is, and you only pay for a few seconds of the code being executed. How Lambda will come to know where the code sits, code is sitting, on what basis it finds it? Well, when you create Lambda so-called functions, and I will be able to show you this probably in session 3, as far as I remember, when you create a function, you need to upload your code to the function, and that particular function you can execute. So Lambda knows where the code sits because you just uploaded your code and allocated it to a function itself. So Lambda knows to execute particular code because you said it to do so. I hope I answered all your questions, and I would like to move a little bit more forward before we're gonna take a little bit of break. So we're gonna go to storage. The optimal storage solution for a particular system varies according to your need, whether you need it or no. Now, the beauty of AWS is that you, in theory, don't need to over-provision stuff. You have a okay, let me make it smaller again. You don't need to provision extremely big hard drives and basically buy them like 2 terabytes, 4 terabytes, or even bigger, and only maybe use 1% of them. All you can do is say, hey, I actually need storage that is maybe 10 gigs because my application is 5, which I don't really want to, spend all this money, and you only pay for 10 gigs. If suddenly you need 20, 50, 100, yes, well, you cannot resize the EBS volume or any block storage, but what you can do is create a new one that is 20, move your data between, and you pay only for 20, which is extremely cheap. So you don't pay up front, you only pay for what you use. Also, file storage. There are services that will allow you to basically store files, like obviously S3, which is an object storage, and file that's kind of related to each other, and you only pay for what you use, which means you uploaded one file, and S3 charges you for 1 gig of storage a month, which means if one file, for example, is 1 meg, that means they will still charge you for 1 gig because it's counted as a 1 gig, funny enough. But if you actually have, 999 megs, they will charge you for 1 gig, and you only pay for amount of files you store, which is absolutely great. And you don't have to over-provision stuff because you're only spending money on the files. You have a freedom. You can say, you know what, I don't really want to keep so many copies of my systems, and I'm keep paying for it lots of money, so I'll just remove them. And once you remove all those copies from S3, suddenly the space is released, and you only pay for what you use. Also, type of throughput you are requiring. Every single instance, bigger it gets, more speed between the instance itself and the hard drive there is. If you have a T2 micro, and I can show you this here, I'm gonna remove this. If you have T2 micro itself that is highlighted, it shows in here EBS optimized maximum bandwidth. It's not available because it's such a small instance. They cannot guarantee performance of the network. But you go for anything like M4 large, for example, and they can guarantee that the network speed between a hard drive and the instance is at least or pretty much similar to 450 megabits. That's a guarantee. Obviously, bigger you get, more speed you will get, which means you can allocate your needs based on not only storage but also how much data will be flying between and how often you access your data. So I hope that that explains a little bit. Let me delete this. Also, you can be charged how frequent you access your data. Now, when you put the data on the S3 itself, you pay for the storage only, but every single time you do operation on it, like read and write or change or modify or delete, you pay for that. Now, AWS will charge you something like a 0.01 US cent for like 1 million operations, which quite likely in the smaller or medium systems, you will probably even never notice on your bill, and I mean it. Usually on the big systems, we have bills for like maybe 3-4 million a month, and the cost for frequent accessing data is maybe $50, which means it's absolutely nothing. So it is amazing how cheap it can get, but bear in mind that they can charge you for how frequent you're using your data. And one of the last things is how available and durable the data is. You can have a different storage types of S3, which we will discuss in detail very, very soon. And depending of how redundant and available your data you want it to be, they will charge you a different amount of money. If you want your data to have 99.9999911 nines, basically, they will charge you 0.03 pence. But if suddenly you say, you know what, actually 99.99 is fine with me because it's still okay, then suddenly the cost goes like twice down, which for most of the people it's okay. You don't run some special systems that must persist of data forever, so it's good. I can see the question here: how is the EBS different from S3? What sort of data is stored in EBS? It's a very good question. Now, it's important to remember what EBS is and what S3 is. S3 is a service which allows you to store files as objects. It's not indexed. You cannot attach S3 to your instance just like that, because it's not behaving as a hard drive. It more or less acts like a Dropbox. When you upload file to the Dropbox, you then get a link to this file, and then you can click on the link and you can download the file. That's more or less what it is. What EBS is more or less like iSCSI, or maybe for those who don't know what iSCSI is, it's basically like a network drive attached to the network via the network cable or fiber or any other means, which means that you can see entire content of the hard drive because it's presenting itself like that. But and also you can index all of the files, which means when you're using Windows and you double click on the folder, you see the content of it. With S3 you cannot. So that's the difference between those two. I hope I explained. So, going further. Now, databases, the optimal database solution for particular systems can vary based on requirements and consistency, how available they are, how partition tolerance and latency, and Amazon provides you multiple options. They have options like RDS, which is a fully managed relational database. You can use MS SQL, you can use Oracle here, you can use MySQL. Basically, pretty much any engine you can think of, quite likely RDS is able to provide. And the beauty of that is scalable as well, because RDS comes with different types and sizes, so you can fully scale to what you need. So when you're starting a new database and it's small, that's great. But when you grow and you have more traffic, you can suddenly make the database bigger, and you're just gonna pay a little bit more for it. But there's no point of blowing the size of the instance at the beginning, because you probably will never use, but you will have to pay for it. Also, another database that is very well known recently is DynamoDB. It's Amazon's version of the database, available only through AWS. It doesn't consist of any equal out there. It provides a single-digit millisecond latency at any scale. That is very important. Now, what it is, it's a fully scalable managed database that, if you program towards it, you can have hundreds of thousands of servers behind, and the database itself will scale up and down without you even knowing, to make sure that it provides the same performance no matter what the traffic is, and that's important. You can also change the number and type of all the nodes in the Redshift, for example, which we discussed before. It's basically a database collector that allows you to basically harvest lots of data from different databases and perform specific operations. So, for example, when you're just storing the data in the Redshift, you can have a minimum amount of nodes, but then you suddenly want to operate on that and have specific analysis of your data, and you're going to run multiple systems against it, and you need performance. In this case, you can just beef up the performance, just basically, I want more. It will grant you the performance pretty much within seconds, and you can run all your operations, which means that you only pay when you use it. Then once you finish, you can scale it down, and you only pay for storage. That's the beauty. Also, it will allow you to use databases like Aurora, or install your own databases from templates like AMIs. Now, one of the cool features of AWS that you will notice quite likely is that you can take images of your VMware, export them into the OVA or OVF format, and you can basically import it into AWS. So if you're running currently VMware in your environment, you can pretty much take all your servers and convert them into AWS format and run them there, which is absolutely great, because you don't need to recreate any of that again, especially when you have complex setup. We use this very often when we do system migrations. It's kind of easy and straightforward. We call it lift and shift, because it's basically lifting whatever is on premise and shifting it to the cloud. It's not probably the greatest way of doing that. There are a few things that will probably change, like IP address, for example, is one of the things, because on-premise you have different range than quite likely you have in AWS, and if the application is sensitive to IP change, then you might have a problem with that. But you can change application to accommodate that, and obviously any move from physical or VM anywhere, it's usually a problem. Now, we are on the slide 31, and there are about 120-30 slides in this deck, and I would need to accelerate a little bit. I will still give you lots of examples, as I kind of tend to do, but I will try to take a little bit less, and we will try to speed up a little bit to get as much as we can during today's session, and I hope that's okay with all of you, and I do apologize if we're gonna speed up a little. So we discussed the databases. We're gonna now go to a space-time trade-off. As I mentioned before, AWS allows you to allocate more memory or more storage or CPU in the different types of instances, which actually makes it much more efficient because you don't need to pay for everything. You can only focus on exactly what you need, which is exactly great. If you have a CPU-intensive tasks, you can specify an instance that has more CPU than memory. If you have a database type that caches lots of things, well, memory would be better. So that's pretty much what it allows you to do. Now we're going to go straight into the cost optimization. What the Amazon says about that is that it is ability to avoid or eliminate an unneeded cost of suboptimal resources. Basically, Amazon encourages you to optimize your environment to the most efficient cost possible by any means. And we're now going to jump straight, and we're going to see what kind of options we have. We have we have transparency that AWS gives you. In fact, AWS actually refreshes their account you use every night, which means you can actually see daily use and the breakdowns, which means any action you take, you can actually trace it back, and you can see how much the change costed you overall. And also they break it down to every single service that you use, which means you can actually even better visualize where the money is going. You can use managed services to reduce the cost of ownership. This is actually very important. Now, if you think about it, to manage a database, you need, first of all, you need a server, some sort of, that sits somewhere. Quite likely someone is managing that. If it's in the data center, you have a bunch of people running, making sure that the electricity is provided, cooling is working, and you need to make sure that someone actually builds the server for you, as well as someone manages the OS on the server itself. There are lots of people involved in all of those operations. Most of the time, when you have a small office, everything falls into you. But in the bigger environments, there are roles that people are doing. Now, what managed services will do, it will do everything for you. All you need to do is basically upload data to the database, for example, and just manage that. Everything else will be fully managed by AWS. It is a little bit more expensive than running the same database on the EC2, for example. But again, looking from cost ownership, so all of those little things that we mentioned, quite likely long term is cheaper to run managed service than do it yourself. Also, trade capital expense for operating expense. That's related exactly to this. You might be given only a fixed amount of money to run your system, which means that it can be up to you if you're gonna make it big or small, but you must fit within a specific bracket just because it was approved, and you have all the tools to do that. You can scale down the system up and down because maybe you have a sale, maybe you have some sort of more performance needed tasks on your backend systems, and in this case you can scale up and down just to meet the demand of the previous section, which means a capital expense. Also, you can stop spending money on the data center operations. Guess what? AWS is a data center and is fully managed. You're paying AWS per hour, as we mentioned before, so you don't need to focus on any of that, which means you have all the time in the world to actually focus on the system itself. You want to design an application rather than waste time on managing this without pretty much the end. So what I'm going to do is jump to the next slide straight away. Also, AWS gives you ability to match supply and demand. As we mentioned before, you, for example, can increase the amount of servers you have because maybe you have a sale or maybe you have some sort of event that requires more processing power. But then during the night, you basically have not much traffic because everyone is asleep, which means the number of servers can go down and up depending on the needs. And that's exactly what it is. Cost-effective resources. Now, AWS itself gives you ability to spin up a very small boxes, so as we kind of saw on the website. The list is very long, and quite likely you will get accustomed with about maybe 5 or 6 of them. I have pretty much my favorites that I use for everything, and you will notice that they kind of a little bit universal. You can use them for multiple different things, but it allows you to go up and down whenever you need. Also, AWS is allowing you to have expenditure awareness, which means they will show you on the daily basis how much you're spending, and that's important. You can also set up a limits and alerts saying that, you know what, I don't want that account to spend more than, let's say, £1,000 a month because that's my fixed budget for my IT. And in this case, you can set up a threshold at around maybe $800. And whenever you reach it, you will get email saying, hey, you actually spent $800. And action can be on you if you want to reduce amount of service within the pool, or you can go to your boss and say, hey, I actually need more money because we're using this very we're using this a lot. Let me just scroll this a little bit. And one of the last ones is optimizing over time. As I mentioned before, quite like at the beginning, you will be given a task of deploying some sort of system, which is great. You don't know how big the system requires to be. They will tell you more or less, maybe I need that amount of CPU, and maybe I need that. And that's fine. Nobody really knows. It's a guess game at this stage. But as time goes and your production and the environment you actually mentioned that you just built, it goes into production and has some sort of traffic, you'll be able to understand over time how much resources are really used for that, which means you'll be able to optimize it, make it smaller, make it bigger if required, and make sure that you're getting every single value out of every dollar you give to AWS. So that's a very good point here. I'll go straight into the next slide. Now, there are a few ways you can achieve match supply and demand. You can do this by auto-scaling, as we mentioned this before, and I will give you much more details once we actually reach this, pretty much this in the future slides. You can have a time-based approach, as I said. For example, during night, you can set up that number of servers can go down to maybe 2 for redundancy, but during the day, you want 5 because you know that your systems are kind of used. So that's a very good example. You can have event-driven approaches, which we mentioned. So if the load goes beyond specific threshold, then something will happen. And also you can have a queue-based approaches, which means you can utilize services like SQS, which is a basic queuing service for all the requests, and more stuff, more things that are in the queue, more servers will spin up and be able to process that, which means you can have a multiple approaches, whichever suits you and your needs for application and business will do. And AWS gives you pretty much all those options just make sure you understand them to be able to use them. Now, cost efficiency resources. You can have on-demand instances. It is instance that you launch and pretty much it. You pay full price for it, which is a little bit of wasteful, I would say, because you don't get any discounts. And if you're running those instances pretty much for all entire time, for like a year, let's say, then quite likely you overspend on it a little bit. The reason is, in this case, we would go for sorry for my big blob. In this case, you would go for reserve instance, which actually you reserve for a year or 3, and the cost for the instance goes anywhere from 20, maybe 30%, all the way to 60, 70% of a whole year. The downside of that is, in this case, you probably won't pay per hour anymore. You can actually pay upfront, but you can make sure that the cost for the instance will actually be guaranteed for the whole year, which means you can save up to 70% of the costs if you know that the server will be running for a year, like production-grade environments. You can have a spot instances. What it is and how it works is basically you bid amount of money that you want to pay for a specific instance. So, for example, if you have an instance that costs 0.50 US cent per hour, and that's the on-demand price. Let me just draw a dollar. Sorry for the doodling. And you can say that I want this particular instance to be launched as a spot instance, but I don't want to pay more for it than maybe 0.20 cents. You can do that. It's a spot instance. Now, if AWS has enough resource to accommodate such a request, then the cost per hour for such an instance can go down to maybe something like even 5 pence or something else. You specify that you maximum want to pay 20 cents, which is great. So for the entire time that the instance is actually running and the bid for the instance is not reached, which means your bid is actually higher than the price of the real instance, spot instance behind, it will be fine. But there is a trick to it. What happens if the demand for specific instance goes up? And that happens very often. You have a Christmas sale, you have a Black Friday, and suddenly all the resources, those unused resources that AWS had, suddenly spike up because everyone wants to use AWS like crazy. So what happened? What happens is suddenly the cost of this particular instance goes actually up, and most of the cases even goes beyond the price on demand. Sometimes we've seen behavior like the instance goes all the way to like $10 an hour, so it's 20 times more expensive. So you need to be careful when you're bidding for it, and I will give you more examples about this before later in the session. I can tell you that more or less on the daily basis, if you have non-critical systems and you just want to run something just to test, you can save up to 8 times the cost of the on-demand instance, which is absolutely great. So you can test stuff without breaking the bank. You can also use services like AWS RDS, which is actually basically managed database. So you're saving all the cost of licensing, of all the hardware and everything else, and you only take care of data itself. And also DynamoDB, which is the same as RDS, with exception it's its own engine, and you only pay for the resource and amount of storage you have, which is even cheaper than that. So I want to skip to the next slide as quickly as we can, so we can cover as much as we can. Expenditure awareness. What you need to do and make sure you understand is that you can allocate tags to an instances or environments. What a tag is basically a little bit of text that you can allocate to EC2, pretty much S3, anything you want. So you can basically tag your resources. So imagine in your company you have 2 departments. One is IT and one is maybe sales. And both of those departments, they run on the same account. However, they pay for their own bill. And how would you determine which account spends how much if you only get one bill? What you can do is allocate the tag, and I'm going to show you all those tags later on as well. And based on that, you basically get a breakdown based on the tags, which means sales guys will get their, you will still get one bill, but you will get also a breakdown of actually the tag that you specified was that much, and the tag that was that much. So you can actually invoice particular subsections of your company or even your clients if you require. The cost allocation report, you can actually have a full breakdown of what you're spending money on and where you're spending money. So if you receive the bill and you're, for example, using multiple services like EC2 and RDS and EC3 and pretty much everything else out there, it will give you a very detailed breakdown. And I mean it very detailed, up to how many hours you're running a particular instance and how much it costed you. That is how much detailed it is. You can also set up billing alerts, as I said before. If you, for example, don't want to spend more than £1,000 to set up billing a little bit less, and you're going to get alert every single time you're reaching that spot, so you don't get a surprise when you open envelope with a bill from AWS. Also, you can use AWS Simple Monthly Calculator, which I will show you as well, which allows you to predict the cost of the environment, because you can actually build, you can drag and drop almost the boxes and the server sizes, and based on that, it will determine how much it will cost to run such a thing per month. So when you're doing a little designs for little projects or big projects, you can actually predict the monthly running cost of the environment, and you can maybe adjust it because nobody really knew that it will cost so much. So you can maybe scale down a little bit on the database, or maybe have less servers, and just to meet the required cost. So skipping to the next. Basically, also AWS allows releases of new products and services. Therefore, it's a good idea to reassess the existing setup to the most efficient way. Every single month, I always get a new notification from AWS, hey, we have this new service. I'm not going to go exactly on all of them right now here, because that's just for the sake of the presentation. But every single month, there's something new. Hey, we introduced this. Hey, we have that. And suddenly you notice that quite likely the service that you introduce, it can be used in your company. And maybe if it cannot, you can ask yourself a question, how can I use it to maybe make my life easier, and maybe make the company save money in the future if they want to use such a thing. So it's very important to understand that with time, new services are being introduced, and you can stop using old-fashioned resources and go fully managed, which means the cost of ownership is much, much lower. Assessing more information. Of course, AWS Architecture Center provides guidance and application architecture best practices to build highly scalable applications in the cloud. You will be able to read pretty much every single article on AWS website once you actually sign into your account, and you'll be able to have the best approaches ever created by the AWS guys and lots of other market leaders, and they will show you what kind of examples you have, which is exactly great. And in this case, you'll be able to imagine and test all of those different principles. As I said before, you have a different web application scenarios that you can actually say, hey, I actually need a fully scalable web application hosting system, and it will actually show you different reference architectures you can use. You can have batch processing, you can have a fault tolerance, you can have pretty much anything else you can think of is probably there. So it's maybe worth before you start playing around with it, see how other people did it, so you can understand how it can be done in the most modern and efficient way. I have a question here from Otis. Should we make an AWS account now for the class? I would say it would be advisable for you to open an account. It's free. It will ask you for credit card details at first, but it will not charge you a penny for it. And you can utilize lots of free tier. Resources from AWS like EC2 and RDS. As long as they're small, they're kind of free for up to a year, so you can play around and understand how it works. And you will actually quickly realize that as complex as it looks at first, it's actually extremely simple. Play around with it. Make sure that you control the cost as well. So every single time it will say, hey, it will cost you that much. Well, don't go overboard, go small instances on purpose, otherwise you will pay for stuff that you don't really use, and you can try and play around with it. So I advise to do that, maybe not at the moment currently, but maybe if you want to try and see how everything works, go for it. Now, AWS technical white papers. AWS provides white papers pretty much for everything you can think of, and it's actually worth reading that. It's kind of technical, but they do not go overboard, which is very good. And I read pretty much majority of the white papers because lots of systems that I actually designed, they were designed before, and someone already came up with the idea, and having a knowledge in your head of somebody else's work will give you a huge advantage, because if your boss comes to you and says, hey, Seb, can you actually give me, can you design the system? I'm like, actually, sure, I can do it today. And he'll be like, oh, actually, Seb knows it all. Well, Seb doesn't. Seb actually knows how other people did it, and that's the truth. So we're all here to share knowledge, and we're all here to have the access to knowledge, and white papers is a very good place to do that. I have a question from Janjit. Is there any plan to host Unix, IC, or Solaris instances on AWS in the future? I actually asked this question quite recently as well. At the moment, there is not a requirement for them. It's not on their roadmap because the need for that is absolutely minimum. They do want to implement this sometime in the future, very, very far, but it's not on the papers. So I would say no at this current stage. You can also use a quick reference deployment in AWS. Basically, you can choose what you want, and it will spin up the whole environment for you. But the white papers you have, it will actually show you how it's being done. So you can have a link server, you can have Exchange server, you can have a remote desktop, and basically it will say how people did it. You can download it via HTML or PDF. So go for it, have a look if you're interested, and you'll be able to understand how other people did it on the cloud. There are some case studies as well that's being done by the big companies like Netflix, Airbnb, Nokia, Yelp, and many others. And it's actually very good, which means that all of those companies have trust, and they went as far as using AWS for their business. Now, Netflix itself was a huge user of AWS for a very, very long time. Airbnb is pretty much entirely sitting on the cloud. I don't know if you know, but the service called Dropbox, that pretty much is very well known in the whole entire world, is actually S3, Amazon S3 bucket. Every single resource that you ever upload and download from there, it all ends on the S3. And that's the core of their system, a simple S3 and a little bit of wrapper around it with the application that can determine what file change on your computer or on the S3 itself. And you have a whole business worth multi-billion dollars right now, only using a single service from AWS called S3, which is absolutely amazing. Now we're going to jump straight into planning and design. Let me go to the first slide. Planning and designing. In this section, we will learn about scaling, loose coupling, redundancy, cost optimization, automation, security itself. So let's jump straight into it. So we're going to follow this particular path. Scalability, and that's very important. So let's jump to this. what scalability gives you is basically virtually unlimited on-demand capacity. So when you can scale, whenever you need it or not. Where there are two ways of scale, vertically and horizontally. As we mentioned before, vertical is basically making box bigger, and horizontal is making more boxes of the same size. So that's possibility. Pretty much, as I said before, I'm just going to skip this. And basically, vertical is basically more memory and more resources. Horizontal is actually adding additional server to be able to handle more people. Now, we're going to get to stateless applications. I know we had the question before regarding stateless and stateful. Now, I'm going to define this as follows. A stateless application is one that needs no knowledge of the previous interactions and stores no session information. An example of that, for example, would be a web server that provides the same web page to any end user, which is stateless, which means nothing really on the website changes. Maybe even if it's dynamic, that doesn't really matter. There's no information kept about the user, which means you can add any number of servers. It's still stateless. Now, pretty much that's what it is. I'm going to define stateful a little bit later. It's somewhere in the slides as well. Push model. What it is, it's a popular way to distribute workloads across multiple resources by using a load balancer, such as the AWS load balancer. What it actually is whenever the requests are coming to the ELB through here, the ELB will push all those requests to all of your resources, and that's a push model. There is also a pull model that we will actually see now, and what it is it's like a message queue. So, for example, you have a queue of requests that you need to fulfill, and the queue filled up. And basically, the queue filled up, and then you have more resources, so you're spinning up more boxes to be able to process this particular request. And they pulling from the queue, which exactly stores all the tasks. So that's it here. And then we have stateless components. We have we can define them as we have DynamoDB, which is a stateless. We have a MySQL server. We have Amazon S3, and we have EFS. Components in the architecture can be made stateless by not storing anything on the local file system, and instances storing user or session-based information in the database, like what I just mentioned, which means all those actually are stateless. And then stateful information. Obviously, one of the big advantages of the stateful is that it persists the data. So some layers of the architecture cannot be turned into stateless components. For example, databases, which by definition obviously consist of data. And a good example is RDS and DynamoDB. Those databases storing the data, and then they actually have constant state available of this particular data. Now, we can also have distributed processing. In the situations when large amounts of data has to be processed, instead of having all of this running on a single box, like in this example here, which obviously it's a little bit of overkill, we can distribute this every single of those little components to a dedicated server to perform its own operation. This way we can make sure that the little box will not explode halfway through and basically stop working. And also we can make sure that we have some sort of redundancy, which means if maybe one server fails, which is fine, we still have 3 tasks that are still performed as they should. Hence, it gives us a distributed processing. Now, what is worth mentioning as well is that AWS need to kind of think about this from a little bit different perspective. When you work in a normal IT infrastructure environment, you treat servers as commodity. You treat them as something that you always will have, obviously up until the stage that will explode or will be decommissioned because they are way too old. But you treat them as a commodity or something that you own. With AWS itself, you don't. You treat servers as fully disposable resource. Which means if you have a simple task of maybe running overnight and maybe indexing some data or maybe copying some files from place A to B just because you have to, you can spin up a whole box as we have here, and the whole box can actually have programmatically configured a specific operation, like take file from A and do something with it and put somewhere in a place B. And actually, once you finish, you know what? Just kill yourself. Basically, just decommission yourself. Hence, you don't pay for it. And that's exactly disposable resources. You only spin it up when you need it. Yes, you might use it for production environments that those servers might be running 24/7, and hence it's not really disposable in this case. But any other task, it can. So that's the benefit of AWS in this case. Automate compute resource initiation. So when you spin up a new server, you can have a few things. You can have it via bootstrapping, so it's a process that during the booting of the server you can perform specific actions. Like, for example, when you're spinning up a brand new box, you say to it, "Hey, actually, you know what? Install, let's say, any service you want, something like maybe a FTP client." And once you install that, connect somewhere through it and download some file via the FTP just because I have to, and then that's it. And that's basically bootstrapping. So it's a whole process from a moment you spun up the box all the way till the box is ready, and then you can perform specific operations. You can achieve the same by actually having golden image, which is a copy of a server that is already with the application after bootstrap, and then you take a copy of it in the point of time, and then you can deploy multiple of those images, or you can have a hybrid. In fact, we use hybrid a lot. What we do in a real world, what we do is we create a golden image of a server with all the OS and everything sitting on it, like even security and all the policies and everything on it, and it's an empty box. It doesn't have anything except a bare base. So what we do is we have a hybrid approach. Then what we do is basically deploy a specific application based on what the server needs to do. We take this particular copy and deploy stuff. If you have a different kind of box, that's fine. It's still using the same resource, but it will push different application, so it will look a little bit different. But the base of the server is exactly the same. So hybrid is very common and very well used. So as I mentioned, bootstrapping is basically taking a data, processing through EC2, and making sure that it comes out with a full application. Golden images, as I mentioned before, can be either done via snapshotting the EC2 and then creating this new instance out of it. You can do the same with the RDS, create a snapshot and then create a brand new database which has exactly the same copy of the data. You can do the same with the EBS, which is actually a storage volume for EC2. And then you can snapshot it, and you can use this to copy the data between, let's say, two regions or attach it to another server. And the most common scenario is basically you take EC2, you create an AMI of it, and then you deploy multiple systems. So if you have, let's say, a web server that you have a static data on it, then you can create AMI out of it, and then whenever you need, you deploy more based on your needs. And it's always the same. It takes few seconds, under a minute really, to spin it up, and you have exactly the same copy of the server in every single place, not only locally, but you can also have it across the world, and that's the beauty and benefit of it. So, as I mentioned before, you can also have a hybrid approach, which I'm going to skip for now because I kind of already explained it. And also, make sure that you understand a simple concept, that you can have a whole infrastructure as a code. That is very important. This is what AWS is about. What you can do is you can specify, hey, I have my system consists of 2 web servers and 1 database server at the end. Yes, you can create this by hand, and you can try to create a copy of it every single time. But why? If you know that you're going to use this all the time, why not just taking this and actually converting this into the Amazon CloudFront? You can use a CloudFormation for that, and you can basically deploy the same code, the same system in multiple places. Now, what CloudFront is you can apply these techniques discussed earlier to entire environments in the individual resources. And automation services. As we mentioned before, there are multiple AWS automation services that are available to you as a developer, for example. You can use Elastic Beanstalk, which obviously is an awesome place because all you need to do is deploy a code to it that you want, and then basically deploys the whole environment and builds everything for you. You can have EC2 auto recovery. Can I go slow? Yes, because sorry. The reason I speed up a little bit was that we really have about 1 hour and 10 minutes to finish about 40 slides, and I wanted to make sure that we do that as much as we can, because I don't really want to leave this session unfinished if possible, and I do apologize for that. I will try to slow down a little bit. We have auto-scaling, which allows you to scale more resources on demand based on the resources needed. You have a Cloudwatch alarms and events, which will allow you to actually specify specific events that happens based on the metrics that you have. Yes, I will try to speak a little bit slower. I'm sorry for that. Also, you can have a ops work and lifecycle event, which actually means that you can redeploy a newest version of the code every single time you have a new release, and that code will be deployed to all your systems automatically and update every single server. And obviously you have loose coupling. What it means is that you don't necessarily want to rely on a single point of failure. So when you have a system that you have a storage and you have a web service, in case of one server fails, it doesn't really matter, because the storage that you use, which in this case can be S3, can still connect to a web server, and application can happen, and a specific action can take place, no matter if you have a web server, 1 down, 2 down, doesn't matter. You still have resource to do that. So you're removing a single point of failure in this case. Also, what you have is a well-defined interfaces. Every single resource that we said before is basically going through Amazon API gateway, and every single resource you always provision, either it's a storage, either it's a compute or database, everything is programmatically defined as an API. You can use a console for that, which most of you probably will. And if you want to do it more automated, you can actually use API calls to the AWS, and you can deploy exactly the same resources via the API itself. Now, also, as we mentioned this before, ELB itself is aware of lots of servers in the pool, so you don't need to specify IPs itself. Hence, service discovery. It is aware of the presence of all those servers, and it knows when they go down. So that's the loose coupling bit ensures that services interact with each other without any prior knowledge of their existence, and that's all as a one system, which is actually integrated with elastic load balancing. Also, you can have asynchronous integration. What it is, it involves the use of intermediate storage layers, such as SQS technique, in order to basically make sure that the servers can actually they do not get overwhelmed with requests. You push all the requests to SQS, which basically is a queue sitting on this particular layer, and the queue can scale and grow as far as it can. But then, more resources we spin, quicker the queue can be tackled, and the queue itself can actually store virtually almost unlimited amount of requests, which means that none of the requests will be ever lost. It will be just processed with a little bit of delay if you have such a system. Then you have a thing also called graceful failure. What it means is, can I give a real-world example of usage of SQS? Sure, I can. Basically, imagine a situation that you have a server that sends emails, and your system is designed to basically generate email every single time user interacts with it. And your server that sends emails has very limited capabilities because you don't really want it to cost a lot. So what you would do is every single time, instead of sending email directly from your application to the email server, which can get overwhelmed when there's lots of requests because there is a spike, instead what you can do is you can actually forward all those emails to SQS service, which will take those emails and create this as a task. And then instead of this, you can take your mail server to connect directly to the SQS and pull them automatically one by one, which means it can only do as fast as it can. So no matter how big the queue or small queue is, it will keep sending emails as quickly as it can up until the queue is empty. Obviously, in the situation like you have a spike where the queue grows terribly quick, the server can only process stuff as quickly as it can, which is fine. But in this case, you will not have a failure because the queue can grow as far as it wants, and it's not critical because the email doesn't need to be sent within the same second. It can be delayed maybe by a few minutes, and that's real example. You have also a feature called graceful failure. What it means is with a system like Route 53, which is basically Amazon's version of a DNS, you are capable of deploying two website locations and via one address, something like a www dot whatever you want. Users can go to the primary source. Now, when the primary source is dead or for any reason is unavailable, you can actually specify in the Route 53 a potential failure, and it can automatically redirect everyone using exactly the same link as before to the new location, and it's fully automated. Once the primary comes back on, it can then transfer everyone back into the primary website, and that's all done by a single service that is basically DNS, which is actually very impressive. Services, not servers. Exactly. AWS is a very well known for implementing pretty much, as I said before, lots of services that are fully managed of pretty much everything you can think of. So database is a RDS, which is exactly fully managed database for you. All you need to do is connect it via a single port and start sending requests. Machine learning, well, there's not really a service out there that you can create out of the box like that. But AWS went beyond and above and created that for you, so you can start using this in your application. Analytics, yes, you can build this yourself, and you can use maybe third-party tools, but AWS does have this feature, so you can use it. You can use search and email. All those features are available to you as a services, but not servers, so you only pay for what you use and resources you require, like amount of email maybe you send, or amount of search queries, or amount of analytics you want to generate, and so forth and so on. Databases. Database usage is not restricted by constraints of licensing, support, and hardware availabilities. AWS offer fully managed, easily scalable services as, and it's worth mentioning, AWS provides services like DynamoDB, Elasticache, RDS, Redshift, MySQL and Oracle. All of them are fully managed. Yes, you can have all of them as well, with maybe exception of Redshift as a server that you want to build yourself, but then you're going to go into the point that you have to manage that, and why do that if you can have AWS doing this for you for a fraction of the cost. Now, redundancy. Redundancy is a very, very important subject that AWS always wants you to know. By redundancy, we always mean that you have more than one resource available in case one server goes down. You have always redundancy, so the task can be always performed. Yes, it might be a little bit delayed because one server can only do half of the operations that two servers can, but it still will be performed, which means you don't have a downtime. And redundancy on AWS is taken to another level. They give you multiple data centers, they give you multiple links, they give you multiple of everything. You just need to know how to use it, and you need to enable this because by default, when you spin up one server, it's only in one data center. So that's important to remember. We also can use such a service as as a standby redundancy. What it means, if you have a database, in case there is a production environment that it goes down, and the business flows based on that is counted in a hundreds of thousands of dollars or any other currency you really want to think of, they usually go for something like a standby database, and it's a very common example. In the AWS, you can create a copy of that particular database directly somewhere else, maybe in another region, and in case there is a big failure, you can quickly fail over to the standby database, and we're going to learn how to do this in the future sessions. And there is active redundancy. What it is basically it's a load balancer. It's fully integrated in the service itself and provides you elastic and fully redundant automatic active connections to every single box, which means if one box fails, it doesn't really matter because the requests are forwarded equally to all the remaining boxes, which means all your tasks are still performed. Also, elastic load balancer gives you the ability to perform health checks, as I mentioned before. So if, for example, your web server doesn't respond on, so it gives you a response to 100, that means something's probably wrong with it, it will be removed from the pool, and will only forward traffic to 2 healthy hosts, which obviously will process the data on both of them, and it can be set up also in the way that if this particular server is dead, it can launch a new one just to accommodate always 3 servers in the pool, just in like this example. Now we have durability of the data. We have synchronous data, we have asynchronous data, and quorum-based. And I think we're going to have this explained in the next slide. Yes, synchronous replication is where the changes, where the write operations and the to the primary source are replicated in the real life to the replication source, which means that all the servers are actually kept in a sync almost near time, because that depends how far they are apart. If you have 2 servers that are based in 2 different places in the world, like one is based in China, another one is in US, just for sake of exercise, the latency between those is counted in maybe like 400, 500 milliseconds, which means the data that is synced, it's not going to be real time, it's going to be always a little bit behind. So that's what we call synchronous replication. Now, asynchronous replication, what it is basically a replication that happens on the primary host, and to the user, the data is being written. But the replication in the backend happens behind the scene, which means it can happen any time after, which means it's not real time. And then we have a third type called quorum replication. Quorum-based replication is a mix of both. It's a synchronous and asynchronous replication. It's basically a hybrid between those two, and that basically I can tell you that it's a mixture of both, because it can actually copy the data directly in the near time replication, but it doesn't have to, and that's exactly what it is. The question I have, those replication, do they is this replication these replications doesn't depend on the databases? It doesn't need to depend on the databases. Yes, databases are one of the things that we can replicate, and in the future you will see that RDS, for example, allows you to tick a single box, and you can create with replicas, or you can have a standby servers, and that's only with one tick, and that is going to be synchronous. You can have asynchronous replication, which means, for example, it doesn't need to be database. Imagine you have a file server, and this particular file server you must sync into other location in the world. It doesn't need to be real time. So what you can have is that you can have maybe a simple a script, or maybe some sort of command or some sort of application that what it will do, it will run every now and then, probably even overnight, because it's the best time to do those things. and it will copy the data from source to the destination and sync them together. However, it's not going to be real time. That's why it is that. I have another question here. Is the replication scheduling based, or it can run while the application is being used and accessible by user? It's actually a very good question. That will all depend on your application. Some applications, for example, like a website. Imagine you have, let me just remove that. Imagine you have 2 web servers, and between those 2 servers, you want to make sure that the content of those 2 web servers is exactly the same. And the reason is, if it's not the same and it's a one production environment, well, then you have a problem. So what you would probably even do here, you can introduce elastic file storage, and that will make sure that the data is basically written to one place and is being actually replicated to another. And that's one of our examples. The example that you don't want to use the synchronous replication is another question from Otis. Is this controlled by application or AWS? Well, AWS itself doesn't really give you, as long as it's a non-managed service, it doesn't give you any replication by default. If you use services like RDS, for example, which is a fully managed service, and you tick the box that you want to have replication enabled, it is a fully synchronous replication delivered by AWS, which means all the servers, database servers in the pool, are actually being synced in a real time, which means in one fails, the other one kick in and will take over from the previous one from exactly the same state. So the answer to this is yes and no, depending on what service you use. So let me skip forward a little bit. And you have also a data center resilience, which means if, for example, you can deploy your application in a single region, let's say in Dublin. Well, guess what? You can also have exactly the same setup in the secondary one, somewhere in the US, for example, with exactly the same state, and but everything off, just to make sure that you don't pay for it. And you can have a full DR, so disaster recovery scenario. And if there's a failure with the one data center, which is very unlikely because in the past 7 years, AWS never actually went down, and they had maybe a little bit of service degradation based on the amount of traffic they had. They had a few DDoSes as well, which they mitigated very well. If ever data center goes down, you can always forward to another data center and enable all those resources by just powering on the boxes, which means when they're off, you don't pay, but when you turn them on, you have a full DR situation. Let's skip another one quickly. So, also worth mentioning, as I said before, every single region consists of multiple AZs, so availability zones. What it means, those are physical data centers, and they are located nearby in about, I would say, anywhere between 20 and 50 miles apart from each other, because that's a physical hardware and location redundancy, and they're all connected via fibers between each other, which means every single time you spin up a server, you can choose which AZ you want. If you want an A, B, or C, and they will physically be sitting in different data centers, which means if one fails for any reason, well, guess what? You still have 2 data centers available, which doesn't really make any difference to you, and applications still can continue to work as normally. So, next slide. Shuffle sharding fault isolation. Shuffle sharding is a practice that sends a few of the requests to some of the resources. This ensures that let me just click it, a shard of a resource is infected or down, and the other shards of resources will be up and running. Basically, what it means is you can set up systems in the way that you can forward specific requests to specific servers and make sure you get correct responses. If you don't, you can basically assume that the system or a server behind it might not work correctly, and hence shuffle and sharding, and that's pretty much what it is about. Also, as always, optimize for cost. So make sure basically right sizing. That allows you to choose appropriate size of instances like EC2, RDS, Redshift, and Elasticsearch. Bear in mind, it's up to you what size you choose. If you choose too big and you pay huge amounts of money, well, that's only your fault. It's not AWS. They gave you ability to spin up anything you want, and you have to pay for it. It's pretty much the same as you go to the IT store and you're trying to buy a server for the database or a normal server. They ask you how much RAM and how much CPU and everything else you want. And if you're gonna say I want 1 terabyte of RAM and I want 16 processors and each one, you know, with hyper trading and all this stuff, they'll give you a quote for £500,000, if not more. And if you say yes to it and you use it only to basically copy file from place A to B, well, it's your own fault. In AWS, you make sure that you choose appropriate size for the task you're doing. Now, elasticity. It's a very, very good subject. AWS offers many elasticity options to help you save money. So, I have a question here. On which database do we shuffle shard typically, or do we do this on S3? We normally don't shuffle shards on the databases. Basically, if you're using RDS itself, basically how AWS works is that it provides you the primary node, and you always connect to it via the DNS name that they provide. So you're not connecting ever to any resource to AWS via the IP address. You always use a DNS name. In this case, they only provide you with one server visible, which means you can write and read to it. What happens behind the scene is the replication, if you enable that, obviously to the secondary machine. And in case the primary fails, then what happens is DNS gets redirected to the other one. So from application, nothing actually changes, which means still server is available. I can still have the same host name, and I have response. Great. Let's continue communication. So coming back to the task here, AWS provides you with horizontal scaling, which means you can add multiple boxes. Also, they give you vertical scaling, which means you can make boxes bigger. And also, you can shut down non-production environments based on the time. And that's actually very good and important. You need to remember, production systems pretty much are running 24/7, if obviously you have such a in your case. But there are lots of other environments like non-production, dev, testing, QA, staging, you name it. I've pretty much heard it and seen it all. And funny enough, the mentality of people most of the time is that they spin up those boxes and running those systems 24/7 just because when the developer wants to connect, they will. But guess what? Developers only work from, let's say, 9 till 5, and that's it. So from 5 till 9, so for quite a while, the server is not being used. It sits there, it's basically doing absolutely nothing, and you keep paying for it. Why? In this case, you can specify that I want to shut down all my servers that are not production between this time and turn them on in the morning again, which means you only pay for 8 hours of using the server in case of 9 till 5, and you don't pay for remaining time. Then the server sits and does absolutely nothing, which actually it's actually about 70% cheaper just to do it, and you still have exactly the same access to the resources, which is a very, very good trick with AWS, and you can save loads of money. So going to the next slide. Now you also have different purchase options, which one of them is on demand. That means that whenever you need instance, you just spin it up, and most of the instances that you spin straight away would be probably on demand. That means you only pay per hour whenever you need it. I would not recommend that for long-term commitments because it's not efficient, and that's important to remember. Reserved instances. What reserved instance is your commitment that you will have this instance or server type or any other resource that AWS provides, like even RDS, for at least a year. In this case, if you commit with AWS for a year, you will have to use the same instance size, pretty much in the same region. And then what happens is AWS will charge you up front money for this box, and for the remaining year, for the whole year ahead, you don't have to pay for it. So what's the perk? Well, the perk is simple. You can save anywhere from 30%, as I said before, to all the way up until almost 70% of the cost of the server, which if you think it's a huge amount of money, especially when you have lots and loads of servers in your organization. And you can actually mostly apply the reserved instances to servers running in production. I have a question here. Reserved instances mean single tenancy. Reserved instances means that you reserve capacity on a single box, yes. And you can have multiple of those. You can say, I want 50 reserved instances of this size. And basically you pay 50 times whatever the price is, and then you just reserve this for a year. You can do it on a year basis, or you can do it up to 3 years basis. And if you're going to go for 3 years, which most of the people don't because you don't really know if your systems will be up and running in 3 years, then you have even better discounts. Most of the people go for 1 year because you still get very good discount, and 1 year is not that much to commit towards. So, another one, spot instances. As I already mentioned before, you bid on the spot instance, and if the bid goes beyond whenever the Amazon is using resources, it will basically terminate your instance. And if it's below, you can keep your instance and you pay only what the instance is worth up until it reaches your bid. Anything beyond, your instance will terminate and you will lose all the data on it. So that's very important to remember. Spot instances are very often used in the environment that you need to perform some calculation overnight or perform some tasks, like maybe I want to spin up a server and copy some files across, and that's all it is. And the spot instance will be perfect for it because it will wake up and basically perform task and just shut down. And obviously there is a risk that the spot instance will be in demand when you're performing the task, hence it will terminate or even not launch. But that's a risk worth taking sometimes if you have a non-production system, just to save some money. I have another question. Can we increase capacity in between from reserved instance? Yes, we can. When we mean capacity, once you purchase the instance, a reserved instance, you are committed to it for a year. If you decide that you don't want this instance after a few days or a month, well, in this case, sorry, but Amazon will not give you a refund. The reason why Amazon does that is because they want to know how much resource and how much capacity they must plan ahead. So if enough people will go to them and say, hey, I need a server for 2 or 3, 4, 1 or 3 years, they'll be able to order enough hardware to accommodate all of that. And that's the perk of that. In reward, they give you very good discounts because they can predict and make sure that they have enough capacity for everyone in the future. So, as I said already, purchasing spot strategies. You can either bid, you can use bidding, bid higher than spot market price to get cheaper overall price. That's exactly, you specify, let's say, 20 pence that you bid maximum, and you pay only what the instance is worth at this current stage, which might be less or more. If it's less, your instance will be spinning. If it's more, your instance will basically terminate straight away. Mixed strategy, which is design applications that use a mixture of reserved, on-demand, and spot instances. And that's a very, very common situation. Imagine you have a production system on almost near production that is not extremely important. You might have two servers that are actually running 24/7 because they're providing constant traffic. And those servers, it's good to actually reserve them because you know they're going to be sitting there for a whole year. But then you have a little spike of traffic and your systems added additional boxes just to be able to handle that. Well, those boxes by standard and default would be on demand, which would be a full price, which is still okay. But if you want to make sure that this particular system can handle the traffic and be cheap, then you can actually use this as a spot instance, which means those 2 instances will be bring to life for around 7, maybe 8 times cheaper than on demand, perform a specific task, and die after this spike is over. So that's basically the idea of a mixed strategy. Now you have a spot blocks. Bid for fixed duration spot instances. Yes, the new feature of AWS allows you to basically say, I need a server for 3 hours, and I need the server to start at maybe 10 because you have a specific task to do. And you'll bid for this particular server, and you'll say, hey, I need this, and I will only pay for 3 hours. And they say, that's fine, that's great, we will give you that. And you can achieve the same principle by actually having scheduled instance. Now, caching. What caching is as simple as caching data means storing previous calculated data for future use, so you don't have to recalculate it. There are 2 approaches: application caching and edge caching. What we would define is by application caching, is applications store and retrieve information for fast managed in-memory caches. This way, application can look for results in the cache first before actually accessing the data. You can use services like Amazon Elasticache, which is a service that provides in-memory cache in the cloud. That's one of the uses. Another one is edge caching. It's a static content such as images, video, or dynamic content, like live video, that can be cached around the world using edge locations. And for that, we would use a CloudFront, exactly what we mentioned before. So if you have a website that is located maybe in the US and you have multiple users around the world, to make sure that all of the users can load a website very quickly and it's very responsive, you would actually use edge caching, because you would actually save all the images in a single bucket, then get replicated around the world in 190 locations via the CloudFront itself, which actually makes it available everywhere in the world. Hence, it's edge location. So you don't access the application itself, because it will go straight to the nearest location. Security. AWS provides multiple security layers available to you, and some of them are as follows. Defense in depth allows you to add multiple layers of protection to your resources. It's entirely up to you how you're going to arrange your security. AWS gives you tools, and you use your tools in the way it suits you and your business. There are multiple different approaches. I cannot give you which one is the best, because it all depends on the application itself. Also, it gives the ability to reduce privileged access, as we mentioned before. So not everyone in your organization must be an admin and have a full right to delete the whole account whenever they please, or they don't even know what they're doing. Security as a code. You can capture all of your security requirements in one script that helps to deploy new environments. And are they changeable as well? Regarding the privileges, the question from, just 1 second. We have a question from Chargeit. Are those chargeable as well? Privileges or what exactly was the question about? If you're thinking about the privileges, no, they're not. You can create any number of users, and all of them are for free. And you can change different privileges. You can assign different policies into it, and all of this is for free. You don't pay a penny, if this is what you meant. And all the security tools as well are free of charge. AWS is very good at that, and they don't want to make money on it. They want to make sure you have all the tools available, so you secure your platform. In the end of the day, you secure also their platform. So they give you all the tools, and they give you all the knowledge you can have in order for you to deploy the best application security you can have. As I mentioned, security as a code already, and then also real-time auditing, test and audit our environments in real time. As we mentioned before, you can have a log of all the live activities on your basically AWS account, which allows you to have a real-time audit and see what actually is going on behind the scene. Now, we're going to skip quickly to monitoring and logging. Monitoring and logging is basically performed on AWS by using a few things. You can use a Cloudwatch itself that is used for monitoring. You can use cloudtrail that is used for logging, and you can use autoconfig, which is a kind of a combination of both, because it's actually auditing if any change occurs in any of those, which means all those three together work as one. Skip another one. So, as I mentioned before, what Cloudwatch does, it monitors it monitors Amazon Web Services, resources, and applications. Basically, it monitors it. It's like a monitor clicking and showing you stats. Collects and tracks metrics, uses alarms and sends notifications, as well as automatically make changes to the resource based on the defined rule. It can send requests of, if, for example, traffic goes beyond 80%, to send action to a specific other service to basically provision more resources, and we'll actually test this a little bit more later. What Cloudwatch events are as follows. Alerts and sends services such as AWS Lambda, Amazon SNS, Amazon SQS, and Amazon Kinesis Stream. Also, Cloudwatch events can be used to schedule events such as snapshot or create an instance or instance reboot. In case, for example, you have instance that got stuck on a 100% CPU for a very long time, and you know this application is not reproduction, but it does specific application. Let's say if the instance is sitting on the 100% CPU for longer than 50 minutes, so 30 minutes, let's say, you know it's not correct, and you can initiate reboot just to make sure the instance is healthy after it reboots, and the application can restart and work like a charm. I have another question here from Taranjit. Are those monitoring tools chargeable or not? The good news is CloudWatch and any of that is not charged as a service. What you will pay is, for example, storage for logs. So if you're using service, which we'll discuss next, then we can skip forward. CloudWatch logs, it will allow you to basically store the logs from any system you want on the S3, and you only pay for the S3 storage, which is very, very minimum. So they can charge you for it, but the charge is extremely minimum and only for storage, not for the service itself. Okay. There are a few limits you need to remember. You can have up to 10 CloudWatch metrics per customer free of per month for free. Anything above that, and they will charge you a very small amount of money. And I would say the amount is so little that quite likely you can treat it almost as free. 10 alarms per customer per month, it's free. That's important to remember as well. That's in a free tier that they want to encourage everyone to start using and testing. In which format are those logs stored? Challenging is asking. Well, those logs are stored in the text file, and you can parse them basically very easily via any Excel or anything, because most likely they are either tab or space separated, so it's actually very easy. You can have 1 million API requests per customer free for a month. You can have up to 1,000 Amazon SNS notifications per month for free. Unlimited number of custom metrics. There's no limit whatsoever. You can have up to 5,000 alarms per AWS accounts, which is a big, big number. Trust me on that. And metrics data is stored for 2 weeks, and that's important to remember. Amazon wants to implement more, and you can actually have this in advanced later on, probably next year. They will allow you to store it up to a year or even more. But at this current stage, it's only up to 2 weeks, which means if you want to see anything beyond 2 weeks, you will quite likely have to use additional tool to get your metrics out, which you can. So AWS provides only up to 2 weeks, which is important bit to remember. Now, CloudTrail. What CloudTrail is, it's recording, sorry for that, it's recording all the API calls for the entire account. Stores and delivers logs files to you. In this case, it's actually S3, which means every single action is being logged, is being written to S3 directly. And also, it provides a history of API calls of your account. Every single thing, as long as it's enabled, and it doesn't have a limit. It doesn't store only for 2 weeks, it stores it forever as a basically text files. You can then take all your text files, parse them somehow in the way you want, and maybe ingest in the application to visualize it if you want. But you have access to it. So, increased visibility. So, CloudTrail, one second. Okay. So, what CloudTrail provides is an increased visibility of your account, which are all the actions taken by the user at any given time, which user has taken actions over a specific time period, what are the sources of IPs of a given activity, and what activities fail due to inadequate permissions, which is important to remember. So you can use CloudTrail to not only trace the user, but also you can use the CloudTrail to monitor if application that you, for example, deployed is maybe missing some permissions and is throwing some errors. So you have certain visibility, and you can adjust permissions accordingly because it will show you that it's missing specific permission. So also, it's very important to remember that, as I mentioned before, all those logs that Cloudtrail is actually generating are being stored in a S3, which means they are stored in a bucket, and you can basically access them. Or if you want, you can glassy them, which means archive for cheaper storage. Out of default, it only stores it on S3, and whatever you want to do afterwards is up to you. Maybe you want to delete those logs. Maybe you want maybe you want to copy them on-prem, or maybe you just don't care about them at all. Or if you want, you can basically copy them into Glacier and keep them for long time as a backup of all the logs for a very, very cheap price. Also, Cloudtrail is fully managed service. There is no management or any really complex configuration. All you need to do is basically enable it. And from the moment you enable that, you need to specify which bucket you want this to go, and it logs every single request forever up until you're going to switch it off. And that's simple as this. And notifications on log file delivery. Cloudtrail uses Amazon Simple Notification Service, also known as SNS, to notify you when the new log gets delivered for a specific event has occurred. You can link Cloudtrail with the notification service. So, for example, if the new log gets rotated or something happens, it can notify user about it. Also, Cloudtrail itself can be integrated with multiple different providers like Splunk, Sumo Logic, or Logi, which can actually parse and visualize those in almost real time. What is actually good about it is Cloudtrail can be extremely, extremely big. It can consist of multiple files, especially when you have a few years of logs. Trust me, you don't want to go through those files and try to find a single event. Why? Because you will have to go through hundreds of thousands of log files. Not only that, each file consists of hundreds of thousands of entries. And finding a single entry in a single file is like looking for a needle in a haystack. Almost impossible. So you can link it with other providers like Logi or Splunk or Sumo Logic, and what they will do is they will actually, you grant them access to your Cloudtrail. They will take all the logs into their system, they will parse them, and actually they will display you some breakdown statistics. Maybe you're looking for a specific thing, and you can suddenly use search to have fully indexed response and a list. So maybe you're looking for a single user that did something, so you can search for a username, and it will basically show you all the records matching this user, which is much, much easier and simpler. Otherwise, good luck with looking through hundreds of thousands of records. So another one, a log file aggregation. It's very, very important as well. Cloudtrail can be configured to aggregate log files across multiple accounts and regions so that the log files are delivered to a single bucket. When we use it and why? Imagine you have multiple accounts because your company wanted to do it this way. Imagine you have 10 accounts. Now, instead of having a Cloudtrail for all of them logging to the same account bucket and for you to go in between different accounts, in fact, 10 different buckets to find something, what you can do is you configure Cloudtrail to go to a single bucket in a single master account, which means it's much easier for you to do it and access that, as well as other services that we mentioned before can access everything through one bucket rather than 10 different ones, which might be a little bit more expensive because they might charge you for a bucket. That's what log file aggregation is. Also, you can enable encryption of all your log files. If, for example, your company says, you know what, we don't really want those logs to be unencrypted because we have specific rules and policies in here, you can enable encryption, and every single thing that ever gets created is fully encrypted with your key and ends up in the S3 bucket. Then basically you need to take this and unencrypt it with your key, and then you can access it. And you can use a service called Amazon Key Management Service, also known as a KMS, to do that. It's very simple. It's basically 2 clicks, and you don't need to know anything or do anything. Everything is fully automated. Also, a log file provides integrity validation. What it means is that Cloudtrail logs stored in your S3 bucket can detect whether they're being modified, changed, or deleted. And that is very important because if, for example, you have a breach of your system and a hacker or someone actually is doing some naughty stuff on your account, quite likely what they will do is try to scramble all the cloudtrail in order to basically hide the activity. So you will know about that because you actually find that those logs were modified. You can enable versioning, which means if they try to modify the file, it will still remain the previous version, which means even though they will try, the previous versions will be accessible to you, which means you can still trace it. I have another question from Charanjit. Will this S3 bucket be private for us? Means that we won't have to go to the public or cloud? Yes, it actually absolutely means this. You can have S3 bucket only for internal use, and you can have a policy specified that only specific servers or users can actually access the bucket. Or if you want, you can have bucket actually facing the internet. By default, when you create a new bucket, it's absolutely locked, which means no access externally will be ever granted. You need to enable that. So that's worth remembering. Very good question. One of the last services in this section is basically AWS Config. What AWS Config is basically it creates a resource inventory, which means it knows what you're currently running, and it knows configuration history, which means that if anything changes, it will notify you about it, which means if you have a production system that you deploy and you don't really want anyone to fiddle around with it and change it, you quite likely enable config, and this way, if anything changes, you will be notified straight away, and it will be shown what actually changed. Okay, I have a question: how config is different from OpsWorks? Well, it's used in a little bit different way. AWS Config is used as a service to make sure that your resources do not change. So it's an audit. It's a comparable tool that finds if anything changes. OpsWorks, on the other hand, it doesn't have this feature. You upload the code to OpsWorks and basically deploy the services for you, the service and every resource you need, but it doesn't manage that. So if anyone actually changes OpsWorks, increases a number of servers or decreases or changes something, you don't know about it. So you can configure config with OpsWorks, and it will act as an audit tool for it. So as I said before, you can use config rules by the IT administrator to quickly determine when and how resources went out of compliance. For example, if it ensures that EBS volumes are still encrypted, maybe if the EC2 instance is still tagged, or maybe Elastic AP to the instance chain. So you sometimes have systems that will be classified as maybe secret, or the data on them would be sensitive to the company, and you need to make sure that this data always persists encrypted. So if you have multiple users in your company and you want to make sure that the encryption is still there, you enable config and you will make sure that it's enabled and nothing changes. And if it does, for any reason, because you assign too much permission to colleagues of yours that did it by maybe by mistake or without even knowing, then what will happen is you will get notification that suddenly the data is unencrypted and something changed, and you will get email or any other form of even text message possible. It also provides you with configuration visibility, which means it can scan for your configuration, and if anything changes or it's abnormal to the normal state or the one that you took a snapshot from, it will notify you via the SMS, which is basically email. And now, continuous assessment. Assess the overall compliance of your AWS resource configuration based on your organization's policies and guidelines. Cloud governance dashboard. AWS config rules give you a visual dashboard with lists, charts, and graphs to help you quickly spot non-compliant resources and take appropriate action. Basically, a AWS config will not do any action on it. It will only notify you, which is important to remember. It is entirely up to you to actually to perform any action or actually do anything about it. Maybe you have a situation like you have a web server firm on the production environment and you have auto-scaling enabled, which means maybe because there was a spike, new servers were added to the pool and you had suddenly more servers. So if you had a cloud AWS config enabled, suddenly it will notice that there's a difference. Hey, I actually noticed a few more servers. Is it okay? It will send you email, and you can then take any action if necessary. But then you will probably log into the console, see actually there was a spike, so it's probably a false positive, and I'm not going to act on that. But it can be helpful, like suddenly someone dropped a server because they did the wrong one, which actually happens more often than you think. And then you'll be notified, and you see actually where's my server, and then you can take action to restore the server, or maybe to find someone who did it and say, please do not do it in the future with a stick, for example. So one of the last subjects we're going to discuss today, sorry for that, is basically a hybrid IT in architecture. What it means, how it works, and how to go about it. Stay with me 1 second. So, let me remove that. Basically, I would give you an example like that. Hybrid infrastructure is every single time that you use a combination of a cloud and a physical hardware on your side, or even VM hardware, or any other resource outside of AWS, would be treated as a basically hybrid, which means you have multiple systems in each of the environments. In the cloud is one of them. In on-prem or on data center or anywhere else, you have another bit. They both work together very well, but they consider it as a hybrid, and that's basically the explanation. So we're going to discuss network and infrastructure. We're going to discuss common controls. We're going to discuss integrated data and control and available tools. So let's jump straight into it. Network. So imagine you have basically a data center in here where you have a bunch of servers, storage databases, and even users. So what would be considered as a network hybrid is that you still run AWS layer in here, but part of your resources are still here, which means you can have EC2 systems, you can have Redshift databases, you can have backup systems in the Glacier, you can use SQS or anything else, and you connect to it via the direct connect, for example, and that would be considered as a hybrid because portion of your systems are still hosted in-house and another portion is in the cloud. Now, it's actually very common. In fact, I would say 99% of businesses out there are hybrid because some of them just started the journey and just starting to migrate systems to AWS, or some of them using AWS already, but they still have in-house systems that must be present because of compliance or maybe data security or something, and they have a hybrid situation. So that's a network. I have a question from Charanjit. Say if we want to create a VLAN tagging for instances interface, is that option available in AWS? No, it's not available because AWS itself does not support it. If you want to create a VLAN between applications, what you will do is you will actually create a new VPC, which is treated as a VLAN, and everything within this VPC container itself would communicate with each other. Anything outside, so any additional VLANs, any additional VPCs you want to create, will not integrate with that. So I hope I answered your question. So data integration and lifecycle management. AWS is used to reliably, cost-efficiently backup and secure your data. You can replicate data across geographical regions, manage the lifecycle of data, or even synchronous, in a sync way, replicate your data to a local AWS data center. And it's actually used almost every single time I can think of it. If you ever want to back up your data, yes, you can use maybe DVDs, you can use maybe some hard drives, you can use even more sophisticated systems like tapes, or you can even have a whole devices like NetApps or any other you can think of, which costs hundreds of thousands, if not even millions of dollars. And it's all great, you can do that, but imagine, you can actually take all the data and put it in the AWS, in the S3, and then Glacier it. It actually performs exactly the same. You store the data anywhere else, somewhere else, outside of the premise, which is the point of the backup itself, and you still have redundancy, probably even more than you would have with the tape, as I mentioned before. So that's pretty much what it is. Common controls and security and access. You have a few ways of basically accessing the the AWS and integrating with this. You can use IAM, so it's AWS Identity and Access Management, also called IAM, and that is built in AWS account level, that you can create users, you can create different permissions, and you can create different policies to grant to all those users. You can also use AWS Directory Service, which is a managed service that can link directly to your Active Directory to pull a list of users, and then you can control them via your AD, via this particular service. And then it allows you to actually create oh, sorry, my mistake. This is where I meant Microsoft AD that fully integrates with your on-prem ID, and AWS Directory Service is a Active Directory style basically control of security within AWS itself, which integrates with Microsoft and other services, but it's managed by AWS. It's a fully managed service, and you can use all three to manage. Majority of the people on the non-enterprise versions will quite likely use this because it's simple. It doesn't require any complexity and any setup. It's basically create a user and assign permission. That's all it is. Yes, it's basically because it's right. You can use an MFA to MFA, which is a multi-factor authentication device. You can use on pretty much all three because it's fully integrated. However, I would say MFA is mostly used in here because when you have directory service and even AD, that quite likely you have your own version of MFA somehow that allows you to integrate. So I would say the most common case is the AWS IAM. So common controls and security access. I know it's already kind of a little bit timeout. I would say we're on the slide 132. We have just a few slides to go, maybe around 5. So I hope everyone is okay. We're gonna stretch the session a little bit longer. Please let me know if it's not okay with you, we can pause. But I would prefer to finish because it's important to me and as well as you to actually get this all information complete. Okay, I have a pretty much go ahead from a few people. That's great. So I will do that. Now, there are 3 types of Microsoft Active Directory integration. There is a Microsoft AD, there is a simple AD, and there is an AD connector. What they're used for and why. When you have a, let's say, a big organization that you want to integrate the access, which doesn't actually happen that often, because even if you have organization with, let's say, 1 million people in it, if such organization exists, guess what? Not all million people will ever access AWS. In fact, I can bet with you that probably less than 100 people will access it because not everyone knows and not everyone is a system administrator. I have never ever seen anyone implementing Microsoft AD because simply there was never a need for 50,000 users from one company to use it. Most common one is basically IAM, as I mentioned, but if you really have to use the AD, people often integrate this with the AD connector, which integrates with your on-prem AD and pulls all the data from there. Simple AD is a AWS version of it, which doesn't integrate with your AD itself. So this one is the most common use. This one I have never seen before, and this some people are using when they don't have an AD server itself. So integrated resource and develop the deployment management. AWS provides monitoring and management tools with robust APIs, so you can easily integrate your AWS resources with your on-site tools. And as I said before, AWS provides you multiple tools, and you can integrate them with via the API. You can integrate with the OpsWorks, for example, or call deploy, which means you can integrate this with your application, and you can have continuous integration, and you can initiate those to deploy new versions of code. I will show you all those examples in the future sessions when you're going to be focusing directly on those.